Market basket analysis is a business intelligence technique to predict future purchase decisions of the customers. It studies customers' buying patterns and preferences to predict what they'll prefer to purchase along with the existing items in the cart. Understanding the importance of this, we have come up with this tutorial on market basket analysis. Now, before we go ahead with the session, I'd like to inform you that we have launched a completely free platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below. Now, let's have a quick glance at the agenda. We start off with a quick introduction to market basket analysis, then we'll learn about a priori algorithm. After that, we'll learn about vector space model. Finally, we'll see how to do sales prediction using machine learning.
So what we are targeting here is fairly straightforward. So we have some data on retail chain store coming from 14 different stores in Chennai. So we are gonna do market basket analysis. So the major trouble here, the necessity for the study is like right now e-commerce is booming. Everybody has a lot of offers in hand, right? So we want to optimize the retail stores for the same thing. So how market basket analysis helps a retail store is in shelf management, and forecasting helps in inventory management for future and setting the sales target, etc. So moving on. So our data came from, as I told, 14 stores of a retail chain, right? So we had a number of variables like bill number, bill date, branch, class, product, and value, quantity. There was something called QBC, which represents code for a product. So we had some 4 lakh rows of data. So what we are doing here is finding association between two products, multiple products, and then we are trying to forecast 5 products sales in the next quarter. So why do we come to top 5 selling product? Will come from some exploratory data analysis. So we did some exploratory analysis just to figure out, look at how the data looks and what can we get basic insight out of it. So while we look at exploratory data analysis, we'll find that majority of the data distribution will follow a Pareto principle kind of thing, where the top 4 or 5 brands or the class of product or the store is capturing majorly 60 to 80% of the sales. So as we can see here, so 20 brands out of 160 contributes to 80% of the revenue. So we are targeting only top 5 of those basically. So essentially looking at the product base for the same thing. So 10 products contribute to 80% of the revenue. So we can focus more on these products rather than focusing on the total entirety of inventory they have. So if we look at a product, like brand product combination, so that comes up later. So right now we look at product. So the top 4 product will be amounting to 60%, close to 60% of sales revenue. So similarly, we are looking at class. So there were multiple class of products, right? So we have something called free gifts here. So free gift is a promotional category which we where the value will be missing, obviously, because it's a promotional category, right? So we can look here also. The top 3 segments, the class of product, contribute to almost 96% of the 94% of the total sales, right? So we look at sales branches now. So this retail store we have data from has around 14. So we had some 12 lakh records for 3-year duration. We chose only 1-year duration to do that, right? So there were total 14 stores here under this retail chain. So we can look the top 4 will be contributing to some 66% of the sales, and top 8 branches are contributing to 90% of the sales. So essentially we can come up to a lot of decision making points here, that the retail chain might need to shut down few of the things or might need to focus on the topmost branches. So then we come up to market basket analysis.
So we have done the market basket analysis. The main purpose of doing the market basket analysis is to decipher the buying trends of the customer. So if, for example, if the customer is buying some X item, then the chances of he is more likely to buy the Y item. So for that we have done the market basket analysis, and that way we can give the suggestion to store owners to keep the frequently bought items together with one another, or they can provide some kind of discounts or combo offers so that it can help in the future sales for the particular store. In data preparation, we have ignored some of the items like free gifts, gift or miscellaneous voucher, etc. Now we have done the item frequency plot graph. I mean, we have plotted the item frequency here, in which the below item frequency plot shows that how the number of times the given items appears in the purchase list. For example, here we can see that stabilizers are 15,000 number of times appearing in out of total transactions. So that way we can get the upper limit for the support rule, for the support value. So for example, if we take the stabilizers, so we can calculate that 15,000 divided for example, we have in total 3 lakh transactions. So in total 15,000 divided by 3 lakh will get around 0.5%. So that way we can find the upper limit for the support value. So after by keeping 0.5% as the support and confidence as 10%, we have got 11 rules in which the support value varies from 0.005 to 0.047. The confidence varies from 0.12 to 0.87, and the lift from 1 to 8. And after removing the duplicate rules, we have in total 7 rules. So in which we can see that whenever a person is buying air conditioner, the chances are the 87% chances are there that the customer will also buy the stabilizer with air conditioner.
The other group which did something on the sentiments, I think you are talking about text analytics, the gentleman. Now this will be some input for you, might see where you can combine. The first time I'm seeing this market basket analysis display in R. You have used R.
Yes.
And so beautifully displayed here. All these are conditional probabilities. Support, antecedents, consequent, A implies B, and all those rules. And the lift ratios, which are more than 1.4, which I said 8 and all that, is something which helps, and see the display of the output. So nicely done. The market basket analysis. First, so far, the whole presentation, this is the first project, I think, in the area of market basket analysis for the retail analytics part. Walmart and others. So this is an important thing. I think this Yugandhar must have taught you that, isn't it? Market basket analysis, a very important thing. Yeah, very useful. So we should reinforce this market basket analysis and pricing analytics in marketing analytics, were very important. Customer retail profitability, segmentation, pricing, and market basket analysis. These 4, if they teach, that is enough. Rather than doing so many other things that are not useful. But this is very useful. Okay, thank you. Proceed.
Similarly, we can see that whenever the person buys cookers and pans, there are 26% of chances that he will also buy induction hob. Now, this is not very obvious condition as compared to air conditioner and stabilizers. So, this 7 rules gives us the data, to keep the items together. So, we have plotted. So, this is scatter plot for these 7 rules. Now, here we can see that, this is the best rule that we have got. And that is that 86% rule that whenever the person buys air conditioner, most likely will also buy stabilizers with that. So, but I'll also want to say one thing, that if the support value is quite low, like we have 0.01 support value when the lift and confidence is high, but we cannot ignore that, because the total number of transactions we are having is 2,18,000. And so that 0.01% stands for 2180, which is a justifiable figure which can be taken into consideration. Okay, so that way we have plotted the 7 rules. Now, So we can say that whenever the lift is greater than 1, the item on left hand side has increased the probability of the item on right hand side in the same transaction by factor numerically equal to left. Whenever the lift is less than 1, the chances of getting the right hand side items bought will be comparatively lesser whenever the left hand side item is getting bought. And when lift is equal to 1, there is no relation between left hand side item and right hand side. Both are independent to each other. So that way the recommendation we can give to retailers from this analysis that they can start a new offer of the mentioned items, also give discounts or making some combo offers to increase the sales and revenue. Okay.
So our next part is the prediction of top selling products. We did some exploratory analysis on the data we have got and found out some top 5 selling products, which are Sony TV, LG TV, Whirlpool Fridge, Samsung TV and Samsung Fridge. We use the ARIMA modeling for prediction of sales because we have more than 38 data points. We did a prediction for week-wise sales, week-wise sequence for entire one fiscal year of 2010 to April 2010 to March 2011. So this is our plan for using ARIMA time series analysis using ARIMA. First, we segregated the data for different products and stored as a data frame in R. And we found that week-wise sales for each product for entire year. That data we converted into a time series. Like for it in entire year we have 48 weeks to 52 weeks. For all the 48 weeks we put the sales of entire week. For week 1, these are sales. For week 2, these are sales. And next we did the ARIMA modeling for each time series. Like we have 5 products, so we have 5 time series for that. And then we plot the series and check the non-stationarity and behavior of the series. If it is stationary, it is not stationary, we have to check it and make it stationary for the prediction. Then the predicting, then we are predicting the ARIMA model for the next 10 weeks for each product. And the prediction is within 2 standard deviation of the range because we want to have a 95% of confidence limit. We use a DeepL-YR library for those summarize and group by summations. So we are doing here ARIMA model for Sony TV. Here we converted the Sony TV. The Sony TV is a class for times is a data frame in which the 4th column is for the number of what is the sales value for a particular week in that one. So we converted that value start from the number 1, that is a week 1, and the number of step is 1, that is going to week wise, and the frequency is 1 because at each week we want to have 1 data points only. So that's why frequency is 1. So we plot the time series for the Sony TV and this is what we got the plot for the Sony TV is there. This is the sales and this is the time frame for these are the weeks in the time frame. Because we have more than 40 data points, so this exponential smoothing is not a good option for that. So we use ARIMA modeling, which is the best option for predicting for more than 40 data points.
Winter-Holt model sometimes can outperform ARIMA.
I don't have so much of idea what the Winter-Holt's. We haven't studied it on.
Yeah, it is not only exponential. It updates. It has different components, a multiplicative approach, trend, seasonality, everything is getting updated, and different smoothing constants, alpha, beta, gamma, delta, they're all there. Mm-hmm. And finally it incorporates and updates the seasonal index, updates everything. Mm-hmm. Peter Winter, even his original paper was first for the Wisconsin telephone prediction. It's a good contender for this because ARIMA, you also require certain other assumptions. And more data points are required.
Yeah, at least 38 data points.
See, that is not something which you really want to focus on. The model, if it is simple and it is predicting much better, that is what you want. ARIMA and all, they are complicated models, and ARIMA 111 or ARIMA 141, a lot of complications quickly come up. Okay, but whereas Winter-Holt model and all these models, they're simple to understand, simple to apply, and they're also equally good at forecasting, like Sir has already said.
Yeah.
So you may just want to try both.
Sure. We will check on that also.
But I appreciate
It's a good effort. There is nothing like, as long as you have reasonably good number of data points, you can go for time series as well as for all types of methods.
Okay. So next we check on this series whether the series is stationary or not. If it is not stationary, we have to make it stationary for the prediction. So we did a certain number of tests like ADF test. So this is the ADF test is saying that if the p-value that is 0.01, if it is less than 0.05, then this gives us the evidence that the series is evidence, not a correct proof that series is stationary or not. It's just evidence of that series is not is a stationary one. But we have to go for the further test as well. The further test is the ACF plots. Here we can see that in ACF plots, the spikes which is crossing the insignificant region, that is mentioned by the dotted lines, is very less. There is only one spikes. That can be done due to the random chance or random error. So we can say that from these two evidence that the series is most probably a stationary one. Null is
The data is stationary.
alternative is stationary. Null is not stationary. Okay.
So you need to have to differentiate once. And then run the regression on, again check for the stationarity.
The one thing I will come forward, like 1 second, just coming forward. We use this auto.arima function. This auto.arima functions automatically throws whether what we have to use at a parameter like PDQ or this arima 0, 0, 0. That is the P, D and Q. So D is 0, the second one. It means that there is no required for the differentiating over here. If it is not required differentiating, that means the series is stationary. This is another evidence from that we are getting from here.
The only thing is you rewrite the hypothesis part. See, very many times people make this mistake. It's also for the class. It is not your fault. This can be the problem with all. What happens is, a very simple rule I will tell you. Null hypothesis is a status quo, the one way of looking at it. Null hypothesis is what you want to disprove, is the null hypothesis. The simple way to understand is you are always interested in proving the alternative hypothesis. So you first formulate the alternative hypothesis. You want to prove something, it is stationary. Then it is not stationary will be the alternative hypothesis. Null hypothesis is a status quo. Supposing you put mu is not equal to phi, for example, you want to test hypothesis against mu equal to phi alternative. I cannot test the null hypothesis. Hypothesis is tested only at the null. So when you are saying not equal to phi, what value will I put? So if you say not stationary, what value will I put? That problem will come. So you have to formulate the null hypothesis in such a way that its rejection leads to the desired conclusion, which is the alternative. And you are always interested in proving the alternative, not proving the null. Ideally, you should reject it. In case you are not able to reject it, you can say in the modern management world, following F.E. Brown of the Wharton Business School, generally a null hypothesis cannot be accepted. But do not reject the null hypothesis doesn't help. So what you can say is, I am accepting the null hypothesis for want of additional evidence. Given the evidence, I am forced to accept.
Okay.
So the null hypothesis should be the other way. You please correct that. What you have written, alternative is the null actually, if I am not mistaken. You try. All I am saying is, you make a comparison. In the automobile industry forecasting study I did for the WAPCO TVS, for the components, interestingly, the Holt Winter gave a better accuracy than Arima. So that is why I am saying do not reject them. Ordinary exponential smoothing will not help. But the Winter-Holt model is reasonably robust. You can try.
Sure.
That has nothing to do with the hypothesis. But in forecasting, why we want hypothesis? You forecast. You have another route, isn't it? But when you are using some of these tests, you need the hypothesis again. That ADF test or all that, yeah. That serial correlation also will come. Autocorrelation, serial correlation. Anyway.
After using that auto.arima function and on the series Y1, which is time series. So we get that output is y1 edema is 0, 0, 0. It means that auto regression factor is also 0. That means that it is not correlated. It is not auto correlated with the previous values of the data. Like it is yt is not dependent on yt minus 1 and yt minus 2. So it is independent of the previous value. And if it is value 0, the middle portion, it is means that there is no differentiating required. The series is integration of order 0. So there is no differentiation required between the yt and yt minus 1. The last value is a moving average. It shows that the 0 value shows that the errors of the previous terms has no impact on the value of the series. So all values are 0. That it means it is a white noise. The series is completely random. So if the series is completely random, so we cannot do a prediction on that series. So it will take a mean value of the series as a prediction for the any time series data. So we come up with that. This is a real-time data. So we come up with a non-stationary data and stationary data and random data. So it is the prediction is not possible here. So we take the mean value as suggested by. So after that, after making that edema model, we come for the prediction for the next 10 weeks using the predict function. So this, as expected, the series will take the value of mean value, that is 2185787 for all the 10 predictions, and the very high standard deviation, that is 936,000. So prediction is like within the two standard deviations is like the blue line shows the forecast, and the two orange lines shows the range of the standard deviation plus 2 and minus 2. So ideally, this is same for the different products like Samsung TV, Whirlpool fridge. We don't do all that showing all the tests. It is similar. The edema we are getting 001. So only the first prediction is different, 1725645. The next one after that it is coming same. Yeah, actually, some offer could be there, like the Diwali sale or kind of same, some kind of. So finally, we have the range of the sales value for the different products. Like for you can say for Samsung TV, it is prediction is 2058593 INR, and the range is from 12 lakh to 29 lakhs. It's a big range for any retail store chain owner, but one should be in the safe zone. Ideally, they should be planned for these ranges also. Any sales could have happened.
To you, that is what I'm saying. You decide sales revenue model, customer loyalty. So can you do market basket analysis and customer loyalty type of a thing? Focus only on the MBA, the transaction, lift ratios, one association, two association items, threshold values, whether it is 20% you fix as the threshold value of a associated probability. If A is bought, B is also bought, some rules, and do a very thorough job of market basket analysis and customer loyalty, and ignore this forecasting time series, because you are mixing two. It's not called for. This is what I feel. In this particular study, do not bring this time series analysis and forecasting. You remove that. What records show those retail analytics? Can I measure some brand preferences, associations? Is Samsung, when they buy Samsung something, is it also they buy the other product of Samsung? Or what is happening? What variables contribute to loyalty? Can I measure customer loyalty in terms of sales? Which variables will be important? Which of the items, which of the associations are important? Do I have a association item 1 with one item association, or 2 item, or 3? What are the things? So if you dig deep into that, you dwell and do a thorough job on a retail analytics project involving market basket analysis and association, revealing and leading to customer loyalty and revenue maximization, I think that will do. For that, when I want to say that this item is associated with this, of course I need to know what will be the sales forecast next time, so that I can keep so many items of this when they buy this. That will be required. But what I am trying to say from a capstone scope point of view, you can avoid the time series forecasting. It is not that forecasting is not required. It will be required here for projections. Next year I am going to do, then these are the items required. So if I have 4 refrigerators, I may have something else. But your study is, any point in time, I will say this is the probability. I would say, why don't you stick to that part? Think about it.
Yeah, initially 4 lakh rows of data.
Generally, that is a pattern. Whenever we do a course also, we jump into techniques. That's a general problem. I have my own views of this missing data. I have 2 strong views. One is, in the manufacturing side, they draw the control charts, upper limit, lower limit. 2 points are going outside. They homogenize. They remove the 2 points and draw the control chart. If there are 2 outliers you remove, all the points will be within control. You will be giving Padma Bhushan to yourself. You don't deserve even a Padma Shri, because I have removed them. Why that has happened, you should know. You cannot remove. Similarly, the missing items, if there are not too many, you don't have to worry. You have to omit that. But if I interpolate by some method, no matter whatever the method, I am making a guess. The missing item should be like this. And if that guess is wrong, the whole analysis is wrong. Wrong to the power infinity. It has happened in the morning also. You saw their own group. When they have not got that, they got a better result. Otherwise, highly misleading results. You want to lead people to a good decision. You should not mislead them, isn't it? So the missing items is a very sensitive area. You must be an expert. Really, how do you deal with the missing value? It's a research going on. List-wise will you do? Will you omit that record? If you interpolate, what is the pattern of the other observations in that record? Can I really interpolate with the median value? Will I make a mistake, or is it robust? If the data itself shows a lot of fluctuations, by anything I do, I may be causing disturbance to the whole system. So these are 2 strong points. But my final advice to you is, your whole capstone, you think about it, is one of market basket analysis and customer loyalty. You focus only that part and write a report, and do little more insight you give. Can I get some brand part separated here? Can I measure the loyalty in terms of repeat purchase? Whatever available from the record, if you are able to write a wonderful capstone project, you can completely ignore time series forecasting, even though it is required for the future, for the retail. But you are doing market basket analysis, because I always feel, don't try to combine and do too many things in a project without a focus. See, you take one aspect, yes, I am going to do. Similarly, the other group I told you, text analytics. Then don't bring text and attribute rating, all those so many ratings, not required. Just focus on that. You can do a very good job. Unless you go very deep into the sea, you cannot pick up or you cannot extract pearls. You need to go deep so that you extract pearls. The same thing holds true. Go deep into something and produce. After all, you are demonstrating your ability to use analytics. It could even be the other group I told that they have done the same thing, Tableau, display and all. I gave a very clear message, business intelligence for this particular thing, and capstone project where you drill down, do all this, that the bike, Divi bike, the same thing I told. Then don't come optimization, some linear programming. They are all non-linear. I tell you, don't have any of them. Why complicate things? Make things simple. Simplify complex things. Do not complicate simple things. That's my lesson. Focus and scalability. Thank you.
Sure. Thank you.
So yeah, this is our capstone project, the digital insurance, personal insurance digital assistant. So it all started from a very small problem statement that, we were just having a cup of tea on one day and we where just we basically come from insurance domain. We have a decade-long experience in that. So what we were trying to see is that why we are talking about how many of us read a policy document, right? So in full its entirety. So maybe we read the first few pages and we don't read the entire section of it. I mean, there are so many things. So what we thought is, okay, is there a problem in people reading a policy document in entirety? Because it started with a conversation, and when we went back to few websites to check the real FAQ questions in the insurance company domain website, we saw similar questions. I mean, probably you'll see what is no claim bonus, what are my exclusions, and what is a network hospital. So these are pretty much available in a document. So these are questions which are available in your document. I mean, if you are able to completely read the document once, you would have made some sense of it, or you would have got that what it is. So some facts we collected about what it is, and say this was one given by the head of the Sun Life Insurance in UK. Say one document needs over 3 hours of reading, and say this is a funny part of it. It has one document on an average. An insurance document has 25,699, which is as big as a Romeo Juliet. Yeah, it's as a Romeo Juliet novel or something like that. So, and this is a real good start that we got. It's a basic. I mean, this was prepared by the Nationwide insurance company, which from US. They say, why don't people read the document completely, and why is that they come to? They realize late when they do a claim, or probably when they want something to search for, when they realize that it's already there in the document and things like that. So, the 53% think it's too long. 43% is complicated and confusing, overwhelming. Sorry. So what we are trying to address here is that we're not trying to make things simple because it's a legal document. If you try to make it simple through your own synonyms or your own content, you might meet something. So what we're trying to use is,
because they don't, too long 53, complicated 43, overwhelming 31, confusing 29. That means overlapping. Somebody could have given in the survey more than one option, two options.
Yeah, this is something which is collected from the net.
So that is true, but we should be able to interpret this. Yeah. Too long is 53% of the people said too long. Yes. Out of the 53% too long, somebody also could have said complicated and all that. Yeah. So is it possible for you somehow to get to the original data and say too long what percentage, complicated what percentage, overwhelming what percentage, confusing what percentage, by adding all the too long separately? I might have told too long, complicated and all, but too long, wherever it appears. If you add the frequency, the total recalls of that too long, and then take that as the basis, the number of recalls will be the sum of all the frequencies. Then out of that, what is the too long? Then what will happen is your percentages will add to 100. The interpretation becomes easier. Right now, the interpretation is hard. Too long, 53% of the people said. In the too long, how many said complicated? Yes. In other words, even when you are using an algorithm like a cart, it's an English language. Yes. If income is more than $90,000, and square footage is less than $20,000, predict owner. Else, if income is less than 90,000 but greater than $85,000 and square footage is less than 15,000 square feet, predict non-owner. So we write a series of nodes. The child node, leaf node, finally it is if then else type of a decision. So similarly here, if somebody said too long and complicated also whatever, then this happens. Else, if somebody said complicated. So unless you do that kind of a text analytics, stating this may have some overlap.
Sure.
So think about it.
Sure.
Just think.
Now, I'm just setting the context. I mean, this is in a different thing. So, what we are trying to see is how to make it simple or easy for people to go and read the entire document per se. we're not just saying don't read the documents. It's not just going to replace that, but we are just trying to create a method to enhance that or supplement that. So I'm talking about the ideation process of it. And so this was the whole ideation about what are the methods that people go back to the companies to get the. So what we thought, these are all the available forums, available methodologies, FAQ center, call center, you can write a mail. So what we thought is, why not create a Q&A system, probably where the insurance, you can access a insurance document logging into a insurance company website. You can have access to it and probably probably would not call it as a chatbot, but more like a messenger, where you can type in a question and get the answer from that document. So that is something that we are trying to achieve in this one. So this is the ideation. The scope definition is, the scope definition is when you talk about it. Now you kind of finalized on a Q&A system is what you're going to finally bring out from your idea. So the scope definition is what kind of a Q&A system would it be? And if you typically the Q&A systems are classified based on their domains and the kind of models that they use, whether they use extractive information or abstractive in the sense a topic summarization kind of modeling, where you create your own answers instead of extracting from the text. So these are the whether it would be a short question or a long question, where you could add 2 or 3 questions together and ask a question. So these are complexities involved in the model or when we design a system. So and is it going to be a conversation, a dialogue system, or it's a no memory system? Basically, what I mean no memory system is that it does not remember the previous question. Say when I say hello David, and say for example David is asking a question, the next question could be, what is my policy premium? It doesn't remember it is David. Say a dialogue or chatbot will remember the previous question and say, welcome David, or David, this is your policy number. So this is a no memory system. So we are just right now focusing on just one single question at a time. So this is what we finalized on. Our Q&A system would be a closed domain, an extractive or short answer, and no memory system. So this is the scope of that system, the Q&A system that we have developed. And the technology that we have used is R. Probably we thought we'll just explore it in R. Not many have done it in R yet. So we tried so many websites and we couldn't. Yeah, R Shiny. We'll probably, when you come to the next slides, our slides are very little. We have only 7 slides, but we'll give you a demo of that R Shiny. So yeah, we kind of went through few. So this is more like a search engine, a mini search engine, where you have to do a lot more of information retrieval. So there are some various models that we went through, and say this is something which was not dealt in the class. So we have to go through this model, understand what this model is about, and then so we just tried 2 models so far. One is the vector space model, which is a ranked retrieval model, and a latent semantic analysis. Kripan will talk more about it, and latent semantic analysis will talk about the word correlation and bring the correlated words even if you don't give that in the input query. So that is a model. So and the data is, since we are talking about documents, we went ahead with the policy documents that we had. We were able to download few documents from the website, and we used a couple of our own health insurance documents and life insurance documents to see whether it's bringing up the right data. So this is the architecture, overall architecture of the system. So we thought we'll have a slide for this. You'll give a user input query, which will be input in the Shiny package, and we execute 2 models parallelly. One is the vector space model, where this is query tagger. This is something which is still under progress. Why the vector space model is more of a bag of words model. Probably we have a next slide dedicated for vector space model to talk about it in detail. But it's a bag of words model where it does not deal with a correlation. It treats each word independently. If you just give policy owner, it does not take it as one single word. It says policy and owner. It's a bag of words model. So it does not deal with correlation. So a latent semantic model is same as vector space model. Probably we'll talk in detail about this TDF, IDF, and the cosine similarity and things like that in these slides to come. Latent semantic analysis runs on top of cosine similarity, but it has a LSA space where it deals with that correlation and brings, even if you don't type a particular word and if you're looking for a particular word in the document, it is able to understand that you are looking for this word, because you build that LSA space using a lot of documents. it does a lot of correlation with that.
This is intellectually of a high order,
Yes.
and the high tech models and all you are doing, and a very wonderful work.
Yes, sir.
But you should explain to the audience and so that they understand.
And the next 2 slides are dedicated for that, sir. One for vector space and one for LSA.
Trying to bring that gentleman here is closely known to me, but unfortunately I am not able to reach him. If I reach him also, he is very busy. Dr. K. Sriram, he was the chief actuary of MetLife, and previously he was an academic finance and control of Indian Institute of Management, Bangalore, and he is a fellow of the Institute of Actuaries, and a very brilliant man, academic. Since you said MetLife, he is into consulting to many companies. He is having a flourishing practice now in Bangalore. He has set up his practice. He is not working anywhere. Outstanding academic. We should bring him for a guest lecture here. He can enthrall. And he told me he has completely gone away from finance to insurance. Brilliant man. You should listen to him. Outstanding. Insurance, and his daughter also has finished associate, and they are practicing. They're doing so well.
So yeah, we have just put a couple of challenges that we faced while doing this model. We just wanted to highlight that because right now all the documents are in PDF format, and we'll open up a particular PDF and we'll show you that a lot of documents are in tabular columns. So it's a great difficulty to bring that into R to bring the sentences out of it.
If you should master is how to excite the audience first. Even this big data fellows who came, several big data people we have been trying, and they are not able to excite the audience. They show a lot of things and technology and all that, but how big data works, can you show one demo of a market churn or credit risk default in the big data environment? That is not happening, but everything else is happening. Similarly, such outstanding work you have done. Gentlemen, this is it. And this is the benefits. The first one, you should start with the Spark, and you have got rattle and all in R. So you should rattle people with that, and then they should be. We don't talk about our problem. We talk about your problem in insurance, and we will give solution to your problem, not our problem. Something like that. You should excite the audience so that the audience will be. Otherwise, I have heard support vector mission, but you have put something else in. And a wonderful high-tech model, latent semantic analysis. So latent view and our latent structure of a factor or structural equation model. What are you talking? I am just thinking in my mind now. This is mind-blowing.
So there are even advanced models where
This itself is a. He says they will go to some advanced models for them.
there are some probabilistic models which we have not tried.
But anyway, so when you are making a presentation, you should come to grips quickly and select those slides which highlights your capability in analytics and how it will help clients and impact factor. And every group should do that rather than going slide after slide. This is another suggestion I have. If you have 20 PowerPoint slides, you should talk only 5, 6. And the way you eloquently speak in a natural style, that will be better. You should not cover every slide in the PowerPoint. Then it will become powerless.
This is the real-time PDF. I mean, this is my document, my healthcare document. So this is a real-time document, that Max Bupa health insurance document. So what we are trying to see is that we are trying to go to write some queries on top of. Okay, this is a real document. So probably you might want to show that what you're going to query.
If you see the document, a policy document which is present in a PDF format, it's quite tough to extract data of a PDF. So if you see, there is multiple ways of data representation in a PDF. There are some tables, there are some paragraphs around it. So what we tried is, when we directly read the PDF through R using a converter and everything, we are not able to extract the data in a proper format. So instead what we did is we choose a simple way where we opened using a Word document, and then saved it as a HTML. So that way it already creates a tags called paragraph tags or a table tags, so that when I read it from R, it can directly take a tables in a data frame format and the paragraphs of the text format. No, I quit my job from United Healthcare 3 months back, so I'm just looking for some other opportunities to
create a Word document with HTML, which is easy for you to program and get. That shows the caliber and the mastery these people have got on the software.
Actually, we tried a lot of converters to convert into a direct, say, Word document or something. But even that is not a very readable format. So some like.
So you will all be pillars of Cognizant. That 2 pillars are here. The Cognizant, we will write an appreciation letter that what these people are doing is amazing, and maybe you deserve something extraordinary in the company as a reward, isn't it?
No, we didn't convert PDF to Word. We read the PDF from a Word document, and then saved it as a HTML.
Using R, they have done all that.
It's not HTML file or something, just a normal HTML page. The reason behind that is many of the PDFs are created from Word documents. So because they basically create from a Word document and then save it as a PDF, that is the reason it is able to retain the same format.
But I think you can edit the PDF with some best software. PDF itself,
PDF
you have to
editor,
be professional.
We need to have that licensed
Maybe if
version.
it is a scan, you cannot edit it, isn't it? If it's a scan, you will not be able to edit it. Yeah. Acrobat Reader.
So, but those are licensed versions and we
Yeah,
are.
correct. Okay, I understand.
So this is how the generally a policy document looks like. So I'll just quickly go to the demo part.
Yeah.
So we have built
One suggestion I will give you: you should become more a marketing person to sell your ideas and impress people, because you have so much knowledge, and you should package it to become a marketable product, not a makeable product. No. Our technology is unquestionable. Suppose you are presenting it to an audience like the IIT and Indian Institute of Science, the mathematicians and others, they will be simply going wonderful, they will say. But to some other audience, now having done all this, what is the insurance benefit and how the company can do? Once you start the gentleman, this is it. And to do this, gentlemen, this is what we did. That should be the positioning. You are starting with a slide, but you should start with that kind of a slide. Having done this, these are the findings, and then how? PDF, this, one after.
Basically, if you see the document, somewhere in the documents, if you see, there are tables like this, which are present in the headers and the data present in the corresponding rows. So because of this, there is a relevancy between the agent name and the header part of it. It just resulted on the particular one single row. What we did is, instead of going with this particular row, we thought of extracting that whole table and then displaying as the next result, so that user won't be able to should not go back to the document again and search it.
Yeah, sometimes one row is relevant, sir, but sometimes the table columns have 40-50 rows. Yeah, suppose a table column explaining your benefits have 40 different benefits, and if I want to display, then I'll cause a visual clutter here. So we thought we'll go with 2 different options. Either you display a single row or if you want, you can display the entire table. Yeah, I mean, what we're trying to do is that right now, if you see, it's probably around 50 to 60% accuracy. It's still not there. I mean, we're not close to 80-90% accuracy. We are trying, relevance of the output. So, yeah, I mean, is that output relevant to me? I mean, when I type agent, am I getting the agent data or something along with that? So,
this particular sentence is treated as a document in the model. So there are 4 terms in this particular sentence. So once we do some basic cleaning for this sentence, there are some stop words. Stop words are the words which are common for the English language and which doesn't necessarily specify any meaning for the particular sentence. So after suppose is a stop word, A is a stop word. So we'll remain with two words or this is and ball. So these are all the stop words. So ball, cricket and field. These three are the words which will remain after my stop word cleansing. So these three words will be represented. So suppose this is one particular document. So there might be n number of documents in the particular frequency of this particular term in this document will be represented in this particular cell. This is how a term document matrix is created. So this is the basis for this vector space model.
Then IDFT you have put again log to the base 10 n divided by the differential FT. DFT you have put. I suppose it is differential of FT.
Actually, we haven't gone through into much of this.
No. Let me raise those points, because being a mathematician, trying to understand your maths, but trying to put some questions to you in that process. Then WTD, you have written 1 plus log TFTD, which is same as the first expression when TFTD greater than 0. So assuming that it holds true, this expression exists into log of n by differential DFT, where if I recall, is it the product, the IDFT is also log of n by DFT. But here you have put log of n by DFT. Is it a natural logarithm, or this is also to the base 10? Or is this, if this is not to the base 10, it is a natural logarithm, then it will be IDFT into log 10 to the base e will come. That is chain rule. So is this expression here WTD, can I take it as 1 plus log TFTD into IDFT? Because IDFT stands for what? That you are multiplying here. So you are multiplying that. So this one you should have written first IDFT and then said that is equal to this. Now is it the base 10 or is it the base E? And IDFT is the differential of IDFT. Am I correct? Okay. Inverse document. What is, so DFT is not the differential. If this is the document frequency, then everything should be to the base 10. Am I right? But how are you changing the weights, sir? All the weights will be changing. The weights are not recursively changed. Then why are you using logarithm here? Suppose I have used a natural logarithm, or the entropy error where I use a log to the base 2. It will not give the same result, because you are multiplying with the log 10 to the base e to get it. So the results multiplied by log 10 to the base e will tally.
Sometimes a word is occurring many number of times and a particular word is occurring very less number of times.
To have a smothering effect.
Yeah, to smoothing effect.
Like a normalizing procedure.
Normalizing kind of thing. After this document matrix created, we'll be going for the weighting, which is the same formulas which you are representing, and the scaling has, after the scaling is done, we'll then move to the term document, term frequency, inverse document frequency. So term frequency and inverse document frequency is used to get the correlation between a particular term and the document. So that correlation is used as to pick the near corresponding most relevant output for when a query is given from as an input to the application.
Just see here, this is another thing. That is why the differentials will come. You are not saying that. Cosine is a monotonically decreasing function of the angle for the interval 0 to 180 degrees. 0 to 180. You are measuring it in pi radians or degrees. So rank the document according to cosine. So your cosine, you will take cosine of what?
See, that's what I'll just show you here.
No. Say here. Okay, that's fine, sir. This is fine. You show me the other results now. You go to that. I understand now.
So this is basically this is a vector space model. Latent semantic analysis is also a similar model built on the cosine similarity itself, but it doesn't compare it doesn't build the term document matrix with the document present given as an input. There is some kind of a supervised learning where n number of documents are given and an LSA space, it's called a latent semantic space, is created, and when a query is input to that particular application and a document is inputted, given as an input.
K-dimension approximation.
These
Now
three
this is-
parameters act as an input, and then the correlation between the query and the document is measured using the LSA space.
So far, what you have put there in the previous slide, the weights and inverse, is ordinary maths. Now it is extraordinary maths. Singular value decomposition, similar to the eigenvalue, eigenvector decomposition. Now, it is used for so many. So, try diagonalization and then orthonormal columns. The columns are orthonormal, orthogonal, orthonormal. Then you reduce it, dimension reduction.
So that's what, like, when we train a LSA space model with say some 10,000 documents, when create an LSA space model, it will be a huge space to get the relations between a document and a query. So to reduce the LSA space model, they use the singular value decomposition so that the size will be reduced and then it will be used for computational purposes.
Very good, excellent. You show me an output for this now. Okay, it doesn't matter, but you just show the R in the R itself.
Okay,
R. Just try, it will be exciting to see the singular value decomposition. The Christchurch book, engineering mathematics book, talks about all that. In other words, what you have done is the zeros represent something and 93 is the iteration that goes close to that zero. That's what you are representing.
No, 93 is a document.
Yeah. No, the values, the cell values, minus 1.645 E minus 15. What does it represent?
It is relation between the term on this particular document.
Yeah, that is so small. It is very close to zero. Perhaps a little statistical. The whole exercise which you have done is on the singular value decomposition, then the vector space method and all that. The accuracy which you are showing is influenced by what variables? In that per PDF you are looking at several things. And if you are able to capture those things also as part of the model, it will go up. It will go up, I can tell you.
We have a tagger which we have not imported.
Yeah, no, that's what I'm saying, that 63 will go to at least 80, 85. I think that is, you have put everything macro. What variables constitute or influence the accuracy which you can retrieve from the PDF and build it in your vector space model?
One part which we are talking about is formatting a PDF in such a way that it is really easy to extract the data. See, insurance company of a particular.
No, but sometimes you may not be able to extract easily the data because the way it is formatted, that is what is available to you. With that, you will have to improve the accuracy. See, you cannot reformat the PDF and tell them, then we will do.
A particular company is drafting their insurance.
No, if the PDF looks like this with these columns and this is the way it is displayed, this will be the kind of accuracy you will have. But if it is this, you should be able to relate it. That's what I'm saying. That part you will have to do. That part, see, the same insurance PDF layout, let's say somebody else has got a different formatting in the PDF. Will it make a difference in the accuracy? Something like a simulation or experiment you will have to do with 4-5 specimen formats. How the accuracy changes, you should be able to capture. Learning by experience. That is like a neural nets, artificial intelligence. But if I change the formatting and replicate it number of times, am I able to get a different accuracy? That we will have to, what is called like an experimentation. But that is your hypothesis. But what I am saying is, have you verified? By doing more tabular, will it go to 80%? Can you prove it? Can you disprove it? That's it. That's what you should do in your study. Thank you.
So quickly coming back to this, what we realized was that instead of displaying one line, if you display the subsequent couple of lines, right, your recall or your relevance goes up a lot. So effectively, what we are saying is a cutoff of 2 for the number of lines that should be displayed along with the first line is probably a good way to display the output. That will increase the relevance quite a bit. This is a plot based on the precision and the recall values that we were able to derive for these two models. Right, left hand side is the LSA and right hand side is the VSAM model. So what we realized is that in the LSA model, the precision initially at least is going to be very low. That is because when you're feeding in a question, it is fetching a. So how do you define precision? Precision is essentially the number of relevant documents retrieved by the total number of documents retrieved. So LSA model, we realize that it is retrieving a lot of documents because of the way LSA is built, right? You're building an LSA space which has a lot of words that could be correlated to the word that we are giving. But in a vector space model, it is essentially looking for those specific words. So the number of retrievals in a vector space model is normally less when compared to an LSA model. So that is the reason why the precision for an LSA model is low. That is if we are giving so we are talking about cosine similarity here. So what we can do to increase the precision is reduce the cosine similarity or reduce the cutoff based on the cosine similarity. If you do that, it will result in pulling the number of rows that is going to be retrieved is going to be reduced, but it will increase the precision. But that will have a negative effect on the recall. The recall is going to be reduced a bit.
Or of non-relevant documents.
So what else can we do with this, right? So one of the issues or while discussing, one thing that we realized was that there are a lot of scenarios where you put in a question and when you search for that question, it will probably search for that word, and we are looking at insurance company here or insurance documents here. So there are a lot of jargons that are being used in the insurance documents which you may not even find in a regular dictionary, right? A benefit could mean a maturity amount. So that kind of a correlation was missing. So if you could build a tagger, a document which will essentially, when you're doing a search, it will be able to map saying that if you're searching for this word, maybe along with that look for these words also. If you do that,
insurance related dictionary kind of stuff.
So that is something that we could look at building that will increase the number of relevant documents that are going to get displayed. So that is one aspect of it. The second aspect of what we are looking at doing is again when we are putting a question, what is your policy term, right? We know from the question that we are looking at some kind of a period, some kind of a date, right? So depending on the outputs that are getting displayed, you could try and do a classification to see what kind of output is it. Is it a period output? Is it some kind of an entity? Is it some kind of a date? If you can try and do that matching, then again we'll be able to display more relevant results. Probabilistic model, I think Kavi already talked about it. So the two models that we have built right now, both are algebraic models. There are other models available which are a little more complex, I guess, much more complex than this.
So before we begin with our work, I'll introduce 3 W's here which I would like to emphasize on. So first W is who. So a quick snapshot on Touchkin. Like earlier in the day, Bindya has introduced what Touchkin does. So they're a healthcare predictive company which has been started like 4 years back. They have 8,000 pilot users. They have data for 15 million sensors. They have recently won a $4,000 funding. So why we are doing this is, so why we are doing sentiment answers for them is the current system, the chatbot, they have a predefined set of questions, and the answers like a patient who's been suffering from diabetics or mental illness, they have predefined answers. So what they are trying to move from a predefined set of questions to a free flow. So how our work can benefit them is, for an example, if a patient is asked, like, how are you doing today? So if a patient replies back saying, I'm doing good today, so it goes on a positive decision. So the next set of questions is based on what sentiment we predict for them. Yeah. So for using sentiment, for working on the sentiment analysis, we have taken the approach of NLTK Python. There are other algorithms available in the market.
You are now not in that company, isn't it? You are, even though you are in the company of other friends, you are in some other company now. Am I right?
So there are other algorithms to do sentiment analysis in the market, but why we chose Python is because it's robust, and the NLTK package within Python itself has a data built from corpus, say, more than 15 million or 15 billion records. So it's kind of trained. So before I proceed further, I would like to emphasize on how English free-form text is been semantic or broken down into NLP language. So the first term, what we call is tokenization. So when a sentence is passed into the machine, it separates every word or every apostrophe or comma used into it. Then what we call is stop words. For example, if a sentence say, I reply back saying, I'm doing good, So the word is redundant. So we don't need that for analysis. So next is called stemming. So stemming, what basically does is, for example, if I give, I have taken a ride on a Ola car. And if there's another sentence which says, I am riding in Ola. So there's a difference. So I've taken a ride which I don't need, which means the same thing. I've taken a ride in Ola. So stemming does that processing of the data. Next is speech tagging. NLTK itself has encoded the parts of speech into separate different forms. Like for adverb it tags as N, for noun it tags as V, for adjective it tags as say some other letter. So it has preposition. It takes care of prepositions, gerunds, jargons, slangs and stuff. So next, what we call is chunking. So chunking is, for an example, if a sentence contains Mr. President Obama, so I have a noun there. Also, I have a verb which describes that noun, or adverb which describes the noun. Mr. President Obama, the greatest. So my greatest is an adverb which is describing a noun. So then I have called name entities recognition. So what does name entities recognition is? So an example, a set of nouns like say football or Manchester United, everything is passed into it. It separates out them, which we don't need it, because here we are trying to predict the sentiment of the patient on their free text.
So we have used custom algorithms. We are using NLTK and NLTK packages, and our main algorithm is naive-based classifier, and we are using we are using naive-based classifier with a combination of hybrid model using our own algorithm for performing the sentiment analysis on the.
So essentially, he has already mentioned, allows us to kind of segment a text, analyze a text, pre-process a text, and to give us a raw formatted thing which can be used for us. Essentially, if you think about in the English language, and what sentiment analysis which the company also wanted was, they wanted on any kind of text being entered to be given as a response of whether it's a positive one, whether it's a negative one, or a neutral one. Now, in any kind of classification or any kind of text which comes into play, it's about trying to process what it is. And since this is with respect to English, it's mostly with trying to identify what kind of words or what kind of semantics those words have got used in it, trying to factor them out, and then create your own algorithms based on your own rules, which would help you determine whether that's in a positive direction or a negative direction. The advantage of using naive Bayes is that naive Bayes has the ability of using training data sets, using some of these positional aspects, the terms which we've used, helps it to build a concept known as feature sets, which we'll describe in the next coming slides, helps it to train data, and then based on the feedback already provided in the training data set that this sentence is a positive or negative, it trains that data set so that next time when we give a sentence, we are able to leverage the naive Bayes algorithm, which already has this probability classified within it, and then take care of our own algorithms built on top of that to be able to further refine it and give a proper response to that.
I just, can you explain what is this naive Bayes?
Yeah. So, naive Bayes classifier algorithm primarily uses a concept of called feature set. So what it essentially does is, and it's something based on both training data set as well as the testing data set. So it's essentially something which does need to have data already provided to it. What it essentially does is, it kind of takes the words which we are providing as
Bayes. Why is it called naive? What is naive and what is Bayes?
Yeah, naive actually is naive.
It is a Bayesian classification. Your entire market basket analysis is also Bayesian theorem. Bayes theorem, conditional probability. Naive Bayes means it is naive. Supposing I assign some arbitrary weights to a problem, you say naive weights. Weights are not fully proven. Similarly, the naive Bayes approximates by an algorithm the entire Bayes theorem, and therefore it is not totally an exact way of doing a Bayesian analysis. Data mining for business intelligence, Nitin Patel's book, Wiley edition, you read. Naive Bayes. Weights are naive when you say that. He is very naive. That means it's simplifying something, not perfect conditional probabilities. If you look at the algorithm, that's what it is. It's not a perfect conditional probability. The naive Bayes is faster than the other Bayes theorem. It's much faster and easy to understand. It simply uses a rule where It circumvents the complexity of the Bayes theorem, but it's using the principles of Bayes theorem. Naive-Bayes classifier. You have a naive-Bayes classifier, then K nearest neighbor classifier. All those things are classifying things.
So they take an average.
You can also use very effectively classification tree, CART. It will work remarkable for a text type of a situation. Gini index you can work out. The maximizing the Gini index of purity leads to higher probability, and it will work for the text very well. It's only counting the words. So it forms a number of crosstabs, works out the Gini index, then combines some of the tables. Suppose weather is sunny and this, it will say whether the outlook is sunny and rain, humidity is normal and this. So it will combine also to maximize the probability of records being placed in a node. So I'm just saying, anyway, you proceed. You have used it, so we will see. And you use Python also.
Yes.
So, okay.
And we do plan to give a small demo post this with respect to any text which is coming in. What we have built on this is, as Sir was saying, there are deficiencies in any algorithm, because at the end of the day, any algorithm is all about trying to calculate the probability of the words being used in it and all that. But there are always going to be scenarios. For example, somebody might make a sarcastic statement. Somebody might use a scenario where there's a negation of a positive kind of statement to be actually deciphered as a negative thing. So what we have done is actually build separate algorithm modules for handling all these kind of type of scenarios.
You are Abhishek. That Abhishek has a style. Now just see. He's trying to.
Yeah. So let's
please proceed.
So as I was reiterating, essentially our things is we are using the base, the training module part being done using Naive-Bayes. But apart from that, we build our own module. So we'll just proceed forward, and this is the summary of each module which we created within it, which encompasses and finally gives us the final algorithm.
So basically, like as Abhishek said, like we have 4 modules here: the training module, classifier module, sentiment analysis module, that and the 4th one is negation that he was talking about. Negation of negation and the negation of a positive module. This was a little challenging for us because when you see a text like "I'm not feeling bad," so it basically it has negative words, but its meaning is actually positive. So I can okay. Next slide. Right. So we got the sample from Touchkin. Like basically, this is the corpus. So we have separate text side like negative and positive. So we have this separate sentence created in our two different texts. So almost of 500 negative and positive sentences.
We used almost 500 positive negative sentences.
So the numbers we got from them were about 600 odd positive text and about 550 negative.
So basically, it should be more data set wise. It should be more content wise. It should be there.
We used about 500 positive negative sentences. We almost used 500 means you are not sure whether it is 500 or less than 500.
You've gone wrong with
No, not wrong. I am just trying to make things simple for you.
Shall we make this correction?
Yeah. Yeah, next you proceed. Yeah.
So this is basically the corpus. What we got, this is a basic corpus. Right.
Yeah.
So we don't have graphs here in our slide, but we can drive you through the algorithm what we have there in our module. So this is the training module what we'll have. So basically how it is.
You have the expression for the algorithm?
Yes. Algorithm.
No, you should show it here. What is the algorithm?
We will show the algorithm
in the demo.
The mathematical expression I want to see.
We have the algorithm, so we'll be showing that.
Right, we have slide for the algorithm files, like what we are using for Naive-Bayes.
You put some thetas and subscripts and all that.
It's not actually an equation. It's a proper.
But an algorithm, if I understand, is a step-by-step method of solving a problem. And it must have some structure, equations, expressions, a combination. So certainly algorithm will also involve equations and inequations, both.
Yes. And we do
inequalities.
We do plan to do that post our slides.
Because if you are pitching yourself as a data scientist, you should worry about algorithm. The set of audience here, if they are data scientists, they will say, show the algorithm. It has a different connotation. Yeah, please proceed. Yeah.
Yeah. So basically, like what we have, like as you saw, like we have the corpus with the positive negative files. So basically, what the training algorithm does, this is the training algorithm which runs actually once. So to train the feature set based on which we make the prediction, what is being used.
And I have another observation which is not peculiar to him. What is your name? Shubham. Which is not peculiar to him. Generally, I find in this younger generation, even when we interview them for some MBA program and all, why that all the time that you see, it's like why so many likes are there? Although I like everyone.
So okay, we got the corpus with the positive negative file. Then we are doing the tokenizing of this, the words. So whatever the sentence we have in the corpus, positive or negative. So we are getting all the words out of that corpus. And based on the speech tagging, here speech tagging is the most important thing what we're doing in NLP. Basically, I'll show you the slide here. This is basically the speech tag. So whatever the words we have, we got from the corpus. So NLP has this functionality in the package which actually assign all the words with a definite parts of speech tagging. So it says, like, suppose noun, we have NN, like noun singular and noun plural. So this is the way it has. So we are taking only we're taking only the adjective, adverb and verb from the, because we don't need anything else from the text or any grammar. So basically we are forming another list as a all word. So here we have all the words which we got from the corpus, and we are doing a frequency calculation for those words and putting into a word feature. Word feature is nothing but like highly occurrence of the words are there in the word feature. So the second model is here is like we got all the sentence from the positive or negative side. So we have this already category for all those sentence, whether it is a positive or negative. Then we are actually finding a features. So we take the words from this document and check whether it is a highly occurrence word or not. And if it is highly occurrence word, we put it as a true, and if it is not, then we put it as a false along with the category. So basically this feature set is a dictionary of list of all the lists. So list has a key and a value. So all the words what we got from this sentence, it will be assigned obviously a value and a true and false according to whether it is present in word feature or not. Then obviously we have positive or negative, we have taken from which corpus, positive or negative. So we have this already. We are doing a shuffling of here a feature set because we don't want training algorithm to be or like doing biasing kind of stuff. So we are doing shuffling of the words so that the training algorithm not get into like because all the sets training set will be to make it unbiased. We are doing a shuffling of it so that classifier should not get the same kind of words every time. So here after shuffling we are actually creating a feature set as a training and testing feature set based on which we will actually do a classification module that is where we are using that naive bias as we have already talked. So a feature set is the most important stuff here based on which the training will happen. So this is okay.
So just to reiterate whatever he just explained, I mean, essentially this flowchart is just explaining our training module part. I mean, this is the training module part wherein the data what we have already provided is getting trained, picked up, and just as I was explaining, the main concept behind the naive Bayes algorithm or any of these things where NLTK or Python is coming into play is the concept of feature sets. Now, essentially what is going to happen is we are trying to create and take out words which satisfy these categories, and then post that What we are just trying to do is because our training data set already provides us the information whether a sentence is positive or negative, we essentially are trying to give weightage to the words present in those sentences which are already being provided to us in training. And that itself is then calculated as a posterior probability things which comes into play when we finally are trying to run this algorithm and providing a sentence to try and predict. So whatever feature sets gets created are essentially getting stored in something known in Python as a pickle module. And those modules are referenced whenever we are trying to use this application as a place wherein when we're trying to provide or trying to gauge what that particular statement is in terms of sentiment. Pretty similar to that. We are using all of those kind of things. Stop words, feature set extractions and all that. It's just that we are also trying to create a biasing thing in terms of the words being used enough to determine which category it should belong to and all that, so that when a sentence comes in, the algorithm can take the words from there and then match it with these existing probabilities to determine which category it would fall in.
Great feeling to win instead of great feel. What will you do?
So again, even if it's a great feeling to win, it gets broken down into the tags of speech in the first part of it. It gets captured, and then the feature set, each of the words which come in these three categories which we are capturing, only those words get picked up. It gets passed to our already used training algorithm document set, and from there the biasing probability is calculated whether this falls in the positive or the negative category. This is what we were just explaining. Where the classifier module works and essentially what it happens and how the classifier accuracy is going to come into play. Nothing different from whatever we have already discussed. When we finally provide a sentence for it to classify, this is the classifier accuracy which comes into play. It's a classifier, inbuilt classifier, which is built into it. It takes the particular set of words which are being passed across to find out the accuracy. It compares it with the probability set of the words which are already existing in our existing data sets, the pickle sets which we've already captured, and then on the basis of that, it finally gives an overall probability of that sentence itself in terms of which category it belongs to.
No, prior is that is already known to you is prior. When I start the exercise, let us say I do a classification. I start with whether positive, negative. It depends on many features. And if I have 14 days weather observed, 9 days are positive weather, 5 days are negative. When I start the exercise, my prior probabilities are 5 by 14, 9 by 14. That is prior. Then I do a posterior. The posterior probability is something which is the contribution of Bayes theorem. And what is important is C given X is determined from X given C. So X given C, I am using it, but my interest is C given X. So ulta, that inverting is the contribution of Bayes theorem. Now many situations we have this. I want to introduce a new product. I have some success rates in the past. Then I want to find out whether I should introduce this. I have some past success rates which are prior probabilities. But if I introduce, I may lose some money and all that. At the same time, I may miss an opportunity. I go to a market research firm to predict the success rate. And market research firm, when I go, I have some past records of their performance. How many times the agency has predicted success of the product when in reality it is a success. So probability of agency predicting success given success. That data I have. But what I need is probability that the product will succeed given agency predicts success, ulta. This is the singular contribution of Bayes theorem. And that is what they are saying. C given X is X given C. X given C is the probability I know, but I want C given X. So the usefulness of C given X will outweigh X given C, but X given, without the help of X given C, I cannot find out C given X. That is the discovery of Bayes theorem, the famous mathematician of the 18th century. And even today, we are doing Bayes regression, so many things, the Bayes theorem application and mathematical properties are there. Even in regression, we are using it. Bayesian probability analysis, it is a powerful revision of probability in the light of information available to you. Based on the information, I revise the probability rates. So if I drilling operation, I get 40% chance I will strike oil before the start of the exercise. By using the Bayesian analysis of additional information, if my drilling probability producing oil becomes 48 or 50, that means that is a power. It gives you, then I will say drilling is worth. So Bayes' theorem gives you that. So a geologist comes and tells, I will predict whether there is oil or not, and he charges $1 million. Or somebody comes and predicts the earthquake. So I have a plant, nuclear plant. In the next 5 years, the earthquake, if it strikes, this plant will be terminated and you have to produce somewhere. So I consult a geologist. What is his success rate? And is it worth paying him $1 million for this prediction? What happens? So the Bayes' theorem comes there. So that is it. So naive Bayes is one of the places it approximates the Bayes' theorem and makes it simpler.
The words, it gets classified in terms of the ratio, and this is the weightages that gets assigned to them.
One very important question, when you say accuracy is 74.69, I give you a classic situation which might challenge you. Supposing your vocabulary which you have built feature does not include a meaning that would have been produced by another word. Okay? But I meant the same thing. Thesaurus is a synonymous word. And your limited feature list may put it in the other category. As a result, it's showing a wrong accuracy.
Yes.
So how do you overcome? Unless you have the entire dictionary, thesaurus, comparisons and all that.
So
this is a real challenge.
This is a real challenge. And
you cannot do otherwise the thing. Otherwise, you should restrict everybody that you should use only these words.
Right. So as I did mention, the way this algorithm keeps getting more powerful is with more...
No, the algorithm is as powerful as the limited vocabulary which you have built in the feature set.
So the feature sets keeps getting enhanced?
Where it gets keeping enhanced?
Every time we are adding more data to our corpus?
No. Supposing I put a sentence. Suppose I say, I anticipate this situation. Whereas the vocabulary there is, I expect the situation. It doesn't recognize anticipate and puts it somewhere, which is wrong.
I think we talked about the word net.
But you should, that means your feature set vocabulary must be a dictionary.
Not necessarily. The feature set...
Or exhaustive treatise, some exhaustive words. So I give you another example. Is the situation harmless? Is it harmless? Somebody says, is it innocuous? So innocuous is not there, it will say wrong. Your accuracy will go down.
So two approaches to this. One is we are using the concept of lemmatization, wherein whichever text is finally being put in order to predict it, we are trying to granulate it to its base words kind of constructions. Second is we are only extracting the three type of words which can come in: the verb, adjective, and the verbs. So verb, adjective, and adverb. These are the only three things which we are picking out from a sentence. If there's any kind of other words,
no, anticipate, expect.
Exactly. So in this particular case, I'm just saying which are the kind of
foresee, anticipate, expect.
Will be if we apply lemmatization to some of these words, they do get converted to its base form. But in this case also, if there's a word which is not completely added across, there is a possibility of that it might.
All I'm saying is your predictive accuracy, which gives here, could have been low if the correct words
are
not taken into account.
And that's one of the reasons why the corpus which we are building is, and since this is getting used in this particular case in a medical app company, the kind of replies which can be anticipated for this particular chatbot application, that's the kind of corpus which we are trying to build up with. What the plan is also is in the future, as and when the application gets more robust and more users start using it, whatever is the free text entries which come in, those keep getting added back as corpus into their system so that the training data can be rerun every week to keep enhancing the ability to predict better things as and when it comes in. Same kind of documents. What they do have is a filtering process also, where they are seeing the kind of number of sentences and the exact number of words. Because we are only adding these things, that kind of thing is being taken as a check before that application works. Your question. Your questions gets addressed because these are separate modules which we have made to handle those kind of scenarios. So there is a case of negation negative. So I am not feeling bad if we use it in a default algorithm based on probabilities, is going to say that it's a negative sentence because of the presence of the word bad and not. So what we have done is we have created a separate module for handling negation of negative type of sentences, which takes care and actually tells you now that this is actually not a negative sentence, but it's a positive. Similarly, we've handled negation of positive modules, wherein somebody might say, I'm not feeling good, but because of the presence of these words and where the way biasing will take place, it will convert this into a positive sentence, but we actually report it as a negative sentence.
Throughout life, what I have learned, I am still learning from you, from all of you, from everybody and anybody with whom I interact, is that when we say something, others should understand what we are saying. Otherwise, they will not believe us. So, how do we simplify things? One example, if you are able to give. I will give you a striking example. In the class, it happened recently. Gini index, sir, you are saying. Show me one example a student wants. So, take one cross tab and show how this Gini index is computed. It may be a very simple table of 3 outcomes. Once they understand, they will accept you. This is what I have learned. Otherwise, they don't accept us. It takes time to communicate. So you have got lot of ideas. For example, is it sentimental analysis or sentiment analysis? That itself could be a semantic challenge. Are you sentimental about your sentiment? Or why is it called sentiments? What is sentiment content in this whole thing? Why the word sentiment? Suppose you do a devil's advocacy and start learning, you will discover a lot of new things. Why is it called a sentiment? Why not sentimental? Or there is no mental in the sentiment? Every sentimental case is a mental case in some way or the other. Is sentiment represents superstition, sentimental? Or what? Is superstition means, is it an irrational faith which I call a sentiment? English itself is like this. Now you come to the local, our languages, Telugu, Kannada, Hindi, Tamil and all that, it will be mind-blowing. Isn't it? But anyway, I admire you for your efforts. But give some example, as Krishna Mohan says.
So it should be more precise.
One sentence, if I say. And the American thing is another complex thing. Don't tell nothing, they say. Don't tell nothing means don't tell anything. Go to the main topic, main point. As a marketer, now come to this. There are too many flow charts and small fonts, which makes things a little difficult.
Those scenarios before we finally.
But the input is high. The input is high. I had medicine last night.
Yes.
I am feeling better now.
Yes.
That means it's positive.
It's positive.
Even without this, I can
We'll
say.
do this. We'll do this. Yeah. That's what. I mean, the demo is going to be interesting because we'll take it, sentences coming in.
Yeah, but let us see whether it is doing.
So we'll have to run it. We have the demos. Okay.
This is what some of you are saying. Whenever something is there, do it. We have to run it. We have to do this. You do it.
We are doing it, sir. We are just.
Well, they were also finding it hard. We have to run it. And he wrote some complicated R script, then he ran it.
That is Geetanjali's fault, sir.
I took medicine, therefore I am feeling better, isn't it? Perhaps I took medicine, maybe a little negative, but then I feel better is positive. Yeah, what is that now? You have run the program?
Try with all the sentences which we had.
Now run the program. I wanna die. That is American style. I wanna die. I've gotten. All that. This is negative, huh? I was feeling better, but today, there is a but you have put, it will become negative.
But today I do not feel good.
I was feeling better yesterday, but today, the moment you put but, it is negative. Gone. But, yes, but.
So that's why it came as negative. We can remove a but and see how it works.
I feeling, remove the but.
Right. So this sentence, so let's just run through the sentences.
The one sentence which you put there, that sentence you run.
So I was feeling better yesterday.
That you have put, but the sentence which you put there, I am feeling better.
We'll do that also.
Yeah.
So I just want to run through these sentences.
I am feeling better. That is there. Run that sentence.
It's here, sir. It's here. I mean, that's a result.
It is not negative. I am feeling better is positive, sir.
It is positive. The fourth one is positive. The neutral one, the one which we wanted to show was this one. I do not feel bad today. This is, if we would have just run it through a default algorithm, this would have given negative. But because of our algorithm which takes care of the positive negation, it actually came out as positive.
Supposing I say, I was feeling bad yesterday, I do not feel bad today.
You can try it.
I was feeling bad yesterday, but today I do not feel bad. That means compared to the relation, I am feeling better. It's not neutral.
No,
the software is wrong.
No, sir. This is something. No, this is something which they wanted, sir. These kind of statements they wanted in neutral category.
Yeah. Now I just want to the point I want to say is, you will have to build the definition for neutral.
Right.
This cannot be considered neutral because the yesterday's state I was feeling bad, but today I do not feel bad is an improvement over yesterday, and therefore today it is positive.
Sir, we can always change that to positive. This was the requirement.
Huh? No. Relation to yesterday, it has become better.
We can.
How can you say it is neutral?
Sir, changing it to positive is not a big challenge. It's that we were successfully able to classify it in this category.
Okay.
That is why we printed it neutral. We could have easily printed this positive. The reason is the clients wanted us these kind of things.
Okay, I agree, Abhishek, I agree. We will have to proceed. I do not want to prolong your conversation. When you say neutral, that means neither good nor bad.
Right.
But that is not conveyed here.
Okay.
Neither good nor bad, because yesterday I was bad. Today I am not feeling bad. It does not directly automatically say neither good nor bad.
Go back to the outputs.
And this particular one he says coming negative. I had medicine and I am feeling good. Because I had medicine, it becomes negative.
So what is that 1.0 next to?
That's just the percentage in terms of accuracy.
It becomes negative.
So that again comes down to
positive.
Yeah. So that comes down to the categories of classifications which we use in our training data set. So in our training data set itself, and we can show the training data set, we have only two classifications. One is positive, negative.
Yeah.
The next set which they want to enhance it is you trying to show that is that they want something similar to be done for mood analyzer. So say a mood can be analyzed in 7 categories. So there can be anger, there can be very anger, this can be frustration. So the concept is going to be similar. It's just that the training data set now is going to have 7 categories of classifications, which then gets fed into the algorithm to actually predict in which category. Even in this one, if they wanted a couple of other categories, which is highly positive or highly negative, we just had to have our training data set accordingly in those.
Cup, when did Sachin holding a World Cup for the cricket? Is never. No, here this is clear. This will show Sridhar negative only because I had medicine. The fact that I am having medicine itself is negative. I am having medicine, I am feeling today good. So medicine produces negative. Yeah, very good, excellent. But one thing, challenges of semantics will challenge you, and the natural language processing is evolving. No software has done anything marvelous, whether it is Python or Tiger or Lion, anything.
We're gonna talk a bit about our project, the Capstone project. What we have worked upon is something we are calling IntelliAgent, just a fancy word, but essentially
it's a very clever ploy. People will think it is intelligent. No, they may not read the A.
After seeing all the presentations today, we probably need to build more intelligence into this, but nevertheless, we'll continue with what we have. So just to lay out the landscape, right? What is the context, business context here? Essentially, we are looking at the service desk space here. So every organization will have typically a service desk. The job of the service desk is any incidents that the issues that the clients might be facing, they'll report those issues to the service desk, and then the service desk technician has to reach out, help out the client with the issue. Both of us from the services industry, I've actually worked in service desk a lot in the past, so I understand how painful that process can be. So the idea was, how can we reduce the number of incidents that go to the service desk? Now, one way organizations typically approach something like this is they would build some self-service portals. I'm sure you would have seen that in your organizations, wherein people can go search for an issue online, and based on what you search for, you might get some results, and you can choose to follow the instructions in those articles to resolve your issue on your own. But the challenge with such knowledge bases typically is that there is very poor adoption of those knowledge bases. Users are so prone to just logging the issue rather than, checking for a solution on their own. So that's what we are trying to fix here, hopefully. We are trying to make self-service or bring, self-service further to the forefront, kind of integrate that into the ticket logging process itself, so that before the client gets to log a ticket, they still have an option, or rather they are asked to choose, to follow up steps in a particular knowledge object, and if that works for them, great. If that doesn't, they can still log a ticket. So we are kind of bringing it into that whole equation. That's the whole attempt. A couple of disclaimers. We wanted to produce an end-to-end sort of a product. This is still a very minimum viable product. It's, definitely there's a lot of refinement possible in this. But we wanted to show you the entire landscape as to, how that product typically would work. The other thing that I want to, point out is we have stuck to techniques that we are fairly familiar with. We have stuck to code that we are fairly familiar with. We have used in the class and all that. So for example, we can probably use better models, and that was a learning for me today, frankly, in terms of how we are matching what the issue the user is describing and what kind of solutions are available in the knowledge base. So we can use more sophisticated approaches, but ours is a fairly simple approach, and we'll talk about that. So those are the disclaimers. With that, I pass it on to Pradeep to, introduce you to the whole thing.
Hi everyone. I'll walk you through the next 4 slides. Start off with, Sarah said about he has talked about the app as such. So the technique we are using is the NLP. And the tools that we are using for creating or designing the GUI is the R-Shiny. And then the core engine is R-Again, which is using text mining. And then the backdrop of the app is MS Access. And so the GUI is mainly designed with R-Shiny, which also integrates HTML and CSS. It can use that. So once the user, before he actually wants to log a ticket, let's say he wants to know what if the solution is already there, he enters the text into the text box and clicks on the submit button, so which then goes to the server where the NLP engine runs, which is actually the R server code again, and then from there it goes and fetches from the knowledge database, which is the KB article, which is in the access, and it retrieves back and comes back to the GUI interface. Okay. So the MS Access database, what you can do is, let's say you have already tickets that are there. You can go and enter the details of it into the database using VBA, the form which we have designed. So we have given features for adding the knowledge articles as well as so this is how the ticketing team can enter the data into the Access database. We have options to add data here. Let's say, you have an existing thing and then you want to edit it, you can select it, and then once you give the keywords to it for a particular problem, you can add it there and then click the update button, which will go and update to the database. Also, if you want to add something new, you can enter the IDs and then do it. Plus, you want to delete something, you can click on the KB title and then delete it. Okay. and this is the interface. We have used Shiny to do the interface. We have actually used text boxes and then the submit buttons. We have actually used low-level codes to design all these fields. So, and the other thing is that in case you don't find a solution for a ticket after you click the submit button, you can actually go and raise the incident straight away. You get an option to raise a ticket straight away here.
Okay, so the NLP code, it's pretty basic. It sits in the server.r file, and that's where all the processing happens. So what really happens is, first of all, we are not using any of the models that we talked about earlier. The whole matching thing it's simple bag of word and bag of words analytics. The way matching happens is using the concept of Jaccard coefficient, which I'll talk about in a minute. Yeah, so we're using Jaccard similarity coefficient to match two vectors. That's essentially what we're doing. Nothing more sophisticated than that. In terms of the steps that happen, first of all, the knowledge base, as you were saying, you go to MS Access database, you read in the KO titles and URLs. Once you have the KO titles, you convert the titles into bag of words, and then you read the issue description from the GUI. That also get converted into bag of words, and then use Jaccard coefficient to match the two bag of words and figure out which bag of word from a title perspective has the maximum coefficient value. You pick that and you demo it to the user. And this, as we said, it's TM package and sits in server.r. I thought it was the cool bits, but probably not so cool anymore, but still, Jaccard coefficient, in very simple terms, what it means is, suppose you have two sets of words. So how you derive the Jaccard coefficient is, what is the number of words in the intersection of those two sets divided by the total number of words, the union. So intersection by union, that's Jaccard coefficient. In terms of how you're calculating it, we're not using any custom functions or anything. We're actually calculating it manually. So you do an intersect and do a length and then figure out the denominator.
Jaccard is important for all of you, particularly those you have got some application. I think your organization, you are going to present tomorrow, isn't it? All the variables, when they are categorical, all the variables. Suppose I want to do a cluster analysis. I cannot use Euclidean distance. I cannot use any other measure other than Jaccard coefficient, similarity. It will match the frequency of multiple responses and then work out this. Essentially what it means is the association of A and B divided by the total frequency of the cross table. Suppose I have A and B. What is the total frequency? In that, what is A and B? So primarily it is the frequency in the association tables or cross tables. You may have a nested crosstabs also, crosstab. So if I want A versus B, A1, B1, A2, B2, A3, B3, A4, B4. So the A1, B1 divided by the total, that will be the Jaccard. Suppose I want the Jaccard coefficient. So the matching, when you say the similarity or dissimilarity between the two sample sets by dividing the size of the intersection, which are common to both, by the union, which is the total words in both the sets. So this is a very important thing while doing clustering of categorical data. Jaccard coefficient is used. All standard data mining books will tell you that. I hope Rajesh Chakotia also would have mentioned it in the data mining course. Am I right? Jaccard coefficient. It's a measure of distance also. And you can do a multidimensional scaling also using Jaccard coefficient. Multiple correspondence analysis Prithvi has done also directly or indirectly would have applied the Jaccard coefficient of associations tables. It's a measure of distance also. How similar are they? How dissimilar are they? So, that sense, this is required. So, I told you that in life, everything is not simple. I want continuous data. I want this. I want that. You may have several demands. But the real data looks like that. You have to find a solution. You cannot say, I have learned analytics at Euclidean distance. Not possible. Even Euclidean, it will not be possible now if he is alive. You will have to go for this kind of techniques. Descartes. Frequencies, multiple responses, and all that when you are counting. Very important measure he has brought now. And I have interacted with him several times. He is a matured master. Anand Sharma. Yeah.
Another interesting thing using the ODBC package. I mean, the first time I used it and I wrote SQL in R, I was like, okay, this is really interesting. So I thought others might find it interesting as well, especially if you're from the BI background, then this would probably be interesting. The other thing is just the whole reactivity concept in Shiny. Honestly speaking, this was probably the most painful thing to code from a, just a coding perspective, because reactivity as a concept is not easy to understand in Shiny. But I mean, in a nutshell, what it means is based on what you are inputting, your display output would change based on that. But then if you're, for example, performing a lot of memory intensive tasks or tasks that will require a lot of computation and stuff, then you can introduce something called conductor in between, and you have them sit there. So this kind of caches your results, and then you don't have to input, go to the input again and do everything. So those are some concepts that are a little, tough to implement. We also use an interesting function. If you're using Shiny, then you'll find it interesting. There's a function called insert UI, which actually allows you to conditionally insert an element in Shiny based upon some action that has happened. So in our case, for example, when you click a button, then something pops up. Until that happens, that screen stays blank. So that was a bit interesting. You would expect that to be there in most dashboardy kind of tools, but it was the first time, I used it in Shiny. It's only available in the Shiny dev package, by the way. So with that said, we'll just do a quick demo. So right now, it's just meant to be a proof of concept. So right now, we are just focusing on, for example, Outlook issues. So we have some 15-20 KOs that we have put in the knowledge base, and we are, showing how people can use those kind of KOs to resolve their issues on their own rather than logging a ticket. Needless to say, that can be extended across, and then you can further refine it by adding tags. For example, I think they mentioned that earlier. So you can add tags and stuff. So in the knowledge base, you have the way we have defined the knowledge base. You have knowledge base titles, and then you have the knowledge base URL. In our case, we are just using support.microsoft links for everything. So when the comparison happens between the two data sets, one is your input, obviously, that is an input string. The other one is your titles of those knowledge articles. So you're actually comparing knowledge article titles with the input and seeing which one has the highest Jaccard coefficient and using that as the output. In the back end, it goes to MS Access database. If you look at the server.r file, for example, then it goes to the MS Access database through ODBC, picks up the titles and URLs. And then we have some functions here. So we are cleaning up the standards that everybody talked about, stop wording and all that. And then we have a function down here wherein we are actually calculating the Jaccard coefficient. So that's just some function we wrote.
What type of desk services? All banks everywhere?
Yeah, as long as your knowledge base support has that relevant articles, it can work with anything.
But have you taken in your capstone any specific case example to illustrate this report? Or
we are focusing only on Outlook related issues. When you have, when you can't send, receive mails in Outlook and anything to do with Outlook messaging, which is a common issue you find in service desks, that's probably one of the biggest ticket drivers. But as they also mentioned in their tag at the end, it's domain agnostic. As long as your knowledge base has the articles, it will do the trick.
Suppose you go to a company and 8, 10, 20 executives are there, their email and correspondence and all. You pick the inbox and message sent, and then subject to this. And what kind of help can they get in future? Can you do something?
Yeah, definitely. Yeah. At the end, that's how you will build your knowledge base based on the kind of issues.
Is it possible in your capstone before you complete the report? Can you add a case study
Okay.
Taking one or two examples and run through fully?
What I did do was in our organization, for example, we have this self-service portal. So I actually looked at the kind of issues outlined for Outlook, and I made sure we captured most of them. But then, yeah, I mean, I haven't done a deep dive into the incident data and looked at stuff.
I think you should do.
Yeah.
That will be very useful.
Yeah, definitely. So in terms of the next steps,
sensors, Internet of Things.
So one thing I do want to call out is, at the end of the day, this was, to be honest, more meant to be a proof of the concept. Now we are trying to do different things. For example, one of the things that we are looking at, for example, is when a service desk agent gets a ticket, then today the only tool that they have to utilize to find out how to solve the issue, they typically have some knowledge articles that they can go through and find out how to resolve the client's issue. One thing we are trying to think about is how we can dig into the old ticket data and figure out if there are other tickets reported for the similar issue in the past and how they were resolved. So we're trying to do those sort of things. At the end, it's still matching two sets of, I mean, at the core, we wanted to understand how can we do this matching thing, right? And this is one way of doing it. This matching concept can be applied to other problems. No, so that problem would have to be approached completely differently from how you get the data perspective. So, for example, you'll have to go into the database itself, and that's going to be a massive database, so it's not going to be easy to load all of that.
There's one interesting thing, I do not know whether it is possible, as a future application of what you have done. If you go to some organization, let's say top 15 people, several emails they have to give on various facets. Suppose you get those vocabulary, that the email thing, and you subject this to this software, and then when they are busy, they are flying, they are going somewhere, on their behalf, just mails can be sent based on the match, the Jaccard coefficient and all that. If this is the type of problem, this kind of mail will be given and it will be sent. Then what happens is that is completely automated within the organization.
Yeah.
A remarkable thing. I think Internet of Things and all that, if you connect and all that, future, several things, sensors and
I'll steal Dr. PKV's quote, "Sky is the limit." So
sky is the limit, yeah.
You keep saying that.
That's why I said Kolmogorov wrote about one of the finest mathematicians this country produced was a student of Dr. C.R. Rao, who is fondly called Srinivasa Varadan in a short form called Raghu, a great mathematician, and went for a doctorate in 1957 with C.R. Rao as the head of the Indian Statistical Institute at the time. And he was doing some infinite space, something he was doing. C.R. Rao was a student of Fisher with brilliant credentials. He said, "You are doing something remarkable. I don't think I'll be able to really think, but I will encourage you, keep doing it." There were no libraries, major research papers and all this person was doing. And when the final thesis stopped, C.R. Rao said, "Whether you get a PhD or not, I cannot decide. There is only one person who can certify you whether your work is worth a doctorate. That is Kolmogorov, the famous probabilist from Russia, I will call him. Because I don't think even I will be able to grasp what you have done. It's going fantastic. Somewhere, I don't know. Either you get or you don't get. Only Kolmogorov can decide." So he came and he wrote that in Russian language. He had an interview, broken English, the Russians, how they speak. After the interview, he wrote some comments and went away. Then C.R. Rao asked, there is another student in ISI. He said, "What has he written? You know Russian language?" Yes, he read, "This work cannot be the work of an ordinary student. It is the work of a matured master. In Moscow, we would have conferred Doctor of Science." That is Srinivasa Varadan. And he did not look back. One of the all-time great medals, lifetime medal from President and all those things he's got. One of the living legends. But that context, even though that we cannot reach that level, this Anand Sharma in this class, this is the work of a matured master. He deserved this appreciation. And I am a very simple man, but I feel that the way he has explained shows the class. Is the title appropriate? Optimizing supply chain operations, is it possible by demand forecasting or demand forecasting in supply chain operations? How will you put it?
Well,
I was going through this. Okay. I wanted to ask you, the group even earlier. Yeah. Can you optimize supply chain operations by demand forecasting?
Right.
Demand forecasting is a standalone. I want to forecast the demand for product.
Yes.
How by itself will optimize the supply chain operation?
I think the problem is specific to the case we have taken here. I'll give you a brief background as to why this...
No, first explain this title. Background is all right.
Yeah.
The thought is if you forecast it properly, accurately, so the supply chain operations would also be accurate. We don't have to have extra...
No, you are optimizing means you are optimizing the cost.
Yes, sir. Yes, sir. I'll come to it. So I'll give you a brief explanation. Yeah. So what happened here is this company we're talking about don't have any demand forecasting.
No. Company may be anything.
Right.
I am asking a very fundamental question first.
It is true in this sense. In this case, it's true.
No, sir. What I am trying to say, do you think you would have lost out if you say demand forecasting in supply chain management? Supposing supply chain operation or the role of demand forecasting in supply chain operations. Then the role of demand forecasting comes. And you said if you forecast demand accurately, you said you can never forecast demand accurately. There is a saying, managers have no choice between forecasting and not forecasting. However, they have choice amongst the methods of forecasting. No method can give 100% accuracy, yet you have to forecast. This is paradox in forecasting.
So, coming back to the title, so the impact of demand forecasting is an optimal supply chain. So for example, if you could predict your demand better, it could result in better savings. Say you need not spend...
impact of demand forecasting on supply chain optimization.
Yeah, okay. So that's where I want to give my 2 cents.
Yeah, okay.
Allow me to
Yeah, I will fully allow you.
Yeah. The problem here is we have been stuck. There was this case in Kaggle. So when PK Visay was here, when he was giving classes, delivering classes, he mentioned about the importance of having the data. Don't come the fag in and then ask for data. That's where we thought, okay, we should go big bang and get some good data. And then we ended up getting 70 million of them. And 75 million, and then we had the infrastructure issues and everything that came about with it. So that's where the genesis of this was. Now, this specific case, this company don't have any demand forecasting at all, completely. So they have put people who actually do the job. So that's why when you're introducing demand forecasting rather than optimizing it, when you introduce demand forecasting, you take the people out of operation and then the cost. So from that angle, if you look at it, probably it makes a bit of sense, or does it not? So you have the people who do the forecasting now, the people who sit there and then are being asked to forecast. Now we come and say, hey, now this is not the way you work. There are companies who do a lot more good job having the computers and systems do this. So with that background, so I'm taking the cost out of the people, the FTEs.
Put demand forecasting first, which is important.
Right.
I'm just saying demand forecasting for optimizing supply chain.
Right, okay.
No, I am still not convinced by your explanation. I thought that you will give such an explanation that I have to accept. But then you are only saying those people did not know how to forecast. They were asked to forecast.
They were manually being asked to forecast. Yeah. So you put people and then put...
So you are saying demand forecasting became a critical critical part for this.
Yes.
Therefore, if I say the title, demand forecasting will have to be highlighted, demand forecasting for optimizing supply chain.
Right. Yeah.
There is some redundancy in the title. Okay.
Right.
What is the redundancy? Why do you need demand forecasting? When you know the forecast,
you reduce waste. etc. And then
it is for better improvement in the
Yeah, lots of-
organization,
yeah.
right? So it means optimization.
Yeah.
So demand forecasting, which one you want to emphasize on?
Right. So
you
demand
you
forecasting,
kind of
yes.
put that as the leading
centerpiece,
thing, okay. Then optimization is kind of follows in automatically.
See, some of them, I tell you my experience. You may or may not take it. There is a famous saying in advertisement. We all say, half the money spent on advertising is a waste. Which half? Everybody says that. So, one of the ads they were explaining in a classic work somewhere. Somebody wanted to advertise for a product, a brand they are producing on camera, alpha camera they called it. The alpha camera did not come in the copy text. They started saying Rolls-Royce, the world best car, was not produced by the largest automobile manufacturer. Similarly, we are the best camera, alpha camera, we are small. So you buy that camera. Because Rolls-Royce was in the copy text first, when the advertisement went, several queries they got, several of them. Everything was saying, please let us know more details about your latest Rolls-Royce car. They did not worry about this alpha camera.
Yes.
Whereas they want to add projects. Similarly, if you are saying optimizing supply chain by demand forecasting, optimizing supply chain only they will think is your project. Your project is more on the demand forecasting. So you can even say demand forecasting for supply chain operations. Even that would do as a title.
Yes. Yeah, I think this example is very relevant. We take that, sir.
No, but don't have to take just because I say you are a thinker. Think about it.
Yes.
Because I was not interested, I was not quite convinced about your title of the project. Yeah, just think about it.
Sure.
The 10th group is coming here, even the very start is remarkable. So far, the problem for me, how am I going to really differentiate? Of course, I will be very fair and just. Everybody has put in the best efforts and every group is trying to do the excellent job. It looks like in search of excellence. Everything is excellent. How can you search in search of excellence? Everything is excellent. And everybody has a viewpoint. I think this shows a remarkable potential in you. Your potential is infinite, which perhaps was not fully discovered by all of us. There's a remarkable potential you have. And why do you say this statistics is hard or this is hard? I think everything is a cakewalk for you now, the way you are doing. Except that I put some questions sometimes. That's my job to see what it is. Yeah.
Just to set the context, so again, going back to the supply chain thing, we all belong to supply chain. That's the reason why we wanted to probably emphasize on supply chain, though we are doing demand sensing primarily. So we kind of, as Varada was saying, that we wanted to get a good data and then problem statement. So related to the industry that we are working on, we are basically from the retail industry. So we stumbled upon this data and the problem statement, which belongs to the bakery industry. So, and we wanted to deep dive in what the bakery industry is all about, and we got very good insights. So we didn't know this prior doing this, getting into the project. Bakery industry in itself globally is about $460 billion industry, which is employing about 2.5 million people. And some of the leaders in the industry are, as is mentioned there, Yamazaki, Grupo Bimbo, and Mondelez International. Grupo Bimbo itself is a $14 billion company, basically a Mexican company. Mondelez International is an American company, again, about $15 billion company, I think. Yamazaki is again $10 billion company, is basically a Japanese company. These are the big players, but we're not considering small players because the statistics don't show up anywhere. How the bakery industry is segmented, there's no surprises there. It's clearly led by the bread rolls, which is kind of a daily consumable product, followed by cookies and crackers, and then cakes and tortillas.
We just show this slide to show what is the volume or scale of the industry. If you could see, this employs about 2.5 million people and it's worth 461 billion. And we are working on the problem for Grupo Bimbo, the second largest bakery manufacturer in the world.
Right.
I'll move on to the next slide. Yeah.
This is an overview about the company Grupo Bimbo.
Yeah, so Grupo Bimbo itself, as I was saying, $14 billion company having its presence in 22 different countries, predominantly in American countries and a little bit of in Europe as well as Asia. It's currently employing about 1.3 million people globally. Obviously, it's led, it's Mexican company headquartered in Mexico.
Just while we're here, I want to get your attention to some of these brands because these our model was more about feature extraction. Get the insights from all the brands and all the products and how do they go together. So just want to get your attention to this. Although not all of these are quite familiar. Bimbo at least, Lara, Tia Rosa. I wasn't familiar until I saw this, did some investigation into what their operations are. So we are going to look at the Mexican market specifically, and the information we had obtained from Kaggle. So there was like 70 million odd data, and they put a problem statement, which is what this is. So surprisingly, that's how it started. Given their huge volumes, Grupo Bimbo have no inventory calculations that's being done by a computer or an algorithm. So it's all being done by the direct delivery sales employees. So as and when they go and deliver, they take the input for, hey, what do you want tomorrow? And we're talking about not just the stores of different format. We're talking about Walmart, which is one of the key supplier vendor for Grupo Bimbo. And we're also talking about the small convenience stores. We're talking about the Kirana shops and everything. So you get vendor stores in all sizes and formats, or the vendors in all sizes and formats that Grupo Bimbo are servicing. And that's what even makes it more surprising. They don't have a forecasting per se mechanism. So, this is what we covered actually. And another key thing is the shelf life of these products is going to be 1 week. So we're talking about bread rolls, you're talking about cakes and all those that are bakery items which are going to go stale within a week or so. And it's quite important they get those numbers right. From that, they want to get away from these direct employees.
Highly people do it, right? So if you get it wrong, the cost is very high.
And then the local knowledge also comes in a lot. So we want to make sure that how can we convert that into algorithms as much as possible. Right? Well, this is just a snippet from Gartner. I don't want to really dwell on this a lot more. Just to give the importance of forecasting accuracy from a supply chain planning perspective. Now this, you might wonder, we're talking about operations and oil planning. Once you enter into the demand forecasting world, it's all a part of the supply chain planning. We call supply chain planning where the forecasting, everything comes in. You have execution where you have the warehousing, transportation, everything that comes in. And then you have the fleet, the last mile delivery. So in supply chain planning, the forecast accuracy, actually, this is a score after they've spoken to lots of the leading retailers and the people who are employed in the retail industry. So that stands out. That's why it's even more important to address this problem from a Grupo Bimbo perspective.
Yeah. So the scope of this project is to forecast demand for week 10 and 11. So what Grupo Bimbo have done, they've given 9 weeks of sales data, sales and returns data. So of which we can use 7 weeks of data to build a model and predict 8 and 9 weeks data. So that's what the objective of this project is all about. Yeah, it's 7 weeks data. So all they've got is 1 million customers and 800 odd products. And it's a time series data where the products are delivered in multiple trips to each customer over a week. So it involves around 75 million transactions. And the test data set.
That is, you are right. In terms of the number of records, is 70 million, what you are saying. But in terms of the time series data, you have only 7 weeks.
Yeah. So that's one of the problem we have. So we can't find demand, the trend or seasonality because it's very short duration.
Do you have any exogenous, any other variables which are related to the growth of the bread
we will come to that. So they've given few variables, but the problem is those variables cannot be used to forecast the demand. So the variables that they've given is of not much use. So that's why we had to do feature engineering a lot. So we had to create our own variables and then identify whether they have an impact on the demand forecasting. So 95% of our work is on feature engineering.
Yeah. I hope you have not made any mistake in the translation.
No. It was fairly easy, by the way. We'll walk through some of the examples. You'll find it interesting.
Yeah.
The tools and technique used. So we want to just give the logos. So Vijay is from consulting background, so you want to apply this consulting touch to it. So rather than putting it a lot more descriptive, you want to see if you can put logos here. And techniques, text mining, I think most of us will discuss. The stop words, everything that we use. I'll touch upon where exactly we're going to use that. K-means clustering as well for the product clustering. And regression tree and XGBoost. Don't ask more questions about it. We're just getting into it.
No, that you cannot say.
I think
as you go to the this, because finally there must be some assessment overall.
Exactly.
For that,
I have in a lighter note I was saying, but yes, you open to, and then that's the only way we're going to learn.
Yeah.
Town state table, which has the agencies, the distribution centers, and the location, town and state, where the distribution center is available. And that's the main data, the training and test data set, which has the transaction ID. Semana is your week. It's a Spanish word, week. Agencia is your agency, which is your distribution center. Canal is your channel. It could be a channel. It's an omni-channel route or a different one. Ruta SAC is your route, which route the product is going to get delivered. Cliente is your customer. Producto is the product. Venta Uni is the sales in units. Sales in units. And Venta is sales in pesos. It's the cost. And Dev is the returns. Dev Uni is the returns in units. And Demanda is the demand that we have to predict. So this is the original data set that we've got.
This is a Kaggle data.
Yeah.
That's the only minus point. Isn't it? Kaggle data is not necessarily representing the actual business scenario.
Okay.
I'm just trying to say that. But it doesn't matter.
Yeah.
It's good. You've got more records and all that. Yeah.
Yeah, that's exactly our problem. So we've got about 75 million odd records, and none of the softwares we had, we tried with R, we tried with SPSS.
Only that is your plus point. Oh, SPSS and all that.
Yeah. No, we tried different softwares to at least to open and view the data. So we couldn't do it at all. So we spent most of our time trying to find which software would allow us to view the data first. Though we've got the entity diagram, we didn't know how the data looked. So that's when, unfortunately we didn't have our Spark or Hadoop class by then. So what we had is we tried a hook and crook method. So Tableau allowed us to view this data set. Yeah. So it took about 5 or 6 hours of running time to visualize this data. And there is a method to extract the data into an Excel from Tableau. So what we've done, so instead of taking the entire 75 million records, so we analyzed the data and then took the sales transaction from one state. So the data set, 75 million records are from 25 different states. So we analyzed it and then found that.
Just a quick question. 800 plus products or 2,500 products?
No.
2,500 products?
Is for the 75 million.
What goes into Mexico? But 8,800 was the product that ultimately came in the category.
So the product master, the master list is about 2,500 products.
In one state.
Yeah. So we ended up taking the state which has the highest demand, which comes around 10 million records.
The Estadio de Mexico, that's the capital city. So
the other way you could have done is, as a representative, even 1 lakh records from, let's say 10, each 10,000 random seed number taken, and you could have illustrated. There's nothing wrong in that. All the states randomly, say 10 lakhs. You define some records, number of records, but representing from all the states, that is also possible.
Okay. No, we'll show you the reason why we've taken one state is because that has the maximum demand.
Yeah, that's okay.
So I've just explained the sampling approach. So what we've done is we've taken the state which has maximum demand, data from the state which has maximum demand, and this is the data description I just explained. So it's all even in English here. So it's Spanish to English conversion. So this is a data structure. So if you look at the data structure, the agency is an integer. So it's actually a categorical variable, but it's given as integer here. It's just the agency ID here.
So have you declared all of them as factors in your program?
Yeah.
Now just see here, this agencia. It has given an absurd result. 1112 first quarter.
Just before converting.
Okay.
where I want to get your attention to is a demander. So just a quick relation. So demander is your demand. So what they do typically is, the spreadsheet we got is, you have a demander which is a demand for any week, 3 to 9, and then you also have the sales for that week that they're able to make, and the returns recorded for this week, which would have actually come the next week. So for example, if I'm on week 3, and I say my total sales is say 1,000 units, and my returns, which is not going to come to me until the next week, but I'll record it against week 3. So if it's 200 units, my total demand would be 1,000 minus 200, which is 800.
So in other words, have you applied opening inventory plus production minus demand is equal to closing inventory? No. When you start, it will be 0. You can assume. Since you are saying after 2 weeks, the returns are coming.
No, returns are going to be disposed. So because these are products with very less shelf life, it's going to be destroyed. So there's no concept of closing stock. It has to be 0.
No, but within 2-3 days, all the bakery, when you go there, they keep the stock for 2-3 days. It is not destroyed the same day.
No, it's 1 week. So the returns would come in the next week. So when you deliver fresh products for the next week, you also collect the returns. So that's one of the reasons why the forecasting accuracy will help them, because they have to collect the returns back and then bring it back to their own base and dispose.
But you will also forecast what is the likely return.
Yeah, so if you can get the sales prediction better, returns would obviously come down.
Okay.
One interesting thing. So what we did is we discarded the ventas, which is your sales, and dev, which is your returns, and we focused completely on demander because they are obviously correlated. So in demander, you'd see that the minimum is 0 in some cases, the maximum is 4,800, and the standard deviation, the third percentile is 6. So see, there's lots of the standard deviation is about 25.
No, there's no standard deviation 25. That's not correct. There's no standard deviation mentioned there. This is a 5-number summary. Mean is mentioned, 5-number summary.
I think we have. When we computed it, actually it came to...
What is the standard deviation you have computed? Can you say that? What you are showing is the third quartile is a 75th percentile.
Yes.
75th percentile is not the standard deviation.
No, we're not shown the standard deviation here. But when we computed it, came to be 25.
Standard deviation is 25.
Yeah.
And maximum is 4,800.
Yeah. And minimum is 0. So it varies with a higher range.
Have you plotted the distribution of the demand?
We have. We have
you show that first.
Yeah, it comes down the line.
But see, what is happening in all your presentation is, what is the pattern of demand? You say it will come later.
No, it's coming. Later. So we are trying to explain the variable. Yeah.
Show the demand pattern distribution first. How does the demand look like? A distribution of the demand. No, that's another problem. The Tableau is a great skill. You will go on doing lot of things in Tableau, including the best graphics. But what is to be shown as a demand pattern? That has to be there.
Yeah, it is there, sir. And we have some insights as well.
Now, what is the curve? Is the demand curve, does it show a shape? What is the shape of the demand curve? Have you done a box plot? Yes. Have you done a shape? What is the distribution?
Yeah, so we will show you. So this is the basis on which we've selected that particular state, Estadio de Mexico.
Yeah, correct.
Can you scroll?
Yeah.
Can you scroll?
Yeah, but go slow. I mean, don't get worked up.
No, you have to scroll.
I think in the process you may press a wrong button there. Just take your own time, no hurry.
This is the inferential statistic we got. So if you see, on an average, there are about 0.1 million customers order every week in that particular state.
Yeah.
And this is the week-wise demand.
Yeah.
And if you look at 50% of the customers come from top 7 towns. So there are about 24 towns.
These are all fine. What is the demand per week? Demand in all those weeks is distributed. What I am telling, let me just explain. You see whether you can click in the Tableau and get the results. What I am trying to say is, supposing the demand varies in certain, your measurement unit is what? Number of loaves or whatever in the bread. How do you measure it?
Units, number of units.
Number of units. Suppose the number of units, let us say, is categorized between 10 to 20, 20 to 30, 30 to 40, millions or whatever you have. 40 to 50, 50 to 60. I plot a curve. How does it look like? A histogram of the distribution of the demand. You will have to show in categories.
See, this is the demand trend here. If you could see, this is across week 2 to 9. So you see, this is the overall demand.
No. This is the total, my dear. The distribution of demand, I'm saying, if the demand is distributed in slabs, if I put weekly demand, how many, every time when I do that, is it between 10 to 20, how many times it has come? 20 to 30, 30 to 40, like that.
We haven't done that statistics.
Yeah,
so
that
what
you
we've done
should
is we've taken the overall demand and also taken the top 5 products and plotted it.
Please listen to me for a minute.
Yeah.
You may have to think about the demand pattern.
Yeah.
When I want to study the demand pattern, we are trying to put them slabs. Now, if that shape the demand behaves like that with a standard deviation, it is looking like a bell curve with a standard deviation of this, then the probability of stock out, probability of demand more than this, less than this and all, you can incorporate.
Okay. Yeah.
And improve your demand forecasting, and you will say the demand will be so many units with this much of probability.
Okay.
So if you plot the demand curve in slabs, first of all, the demand, I'm not talking about the demand curve means price will come. Just how the demand is distributed.
Okay. Yeah.
You are now amalgamating everything and showing a macro.
Yeah.
Total demand, and then you are drawing a graph, it looks like a straight line. But that is not the shape of the demand.
Okay.
Think about it.
Yeah. So this is product-wise demand across weeks.
Yeah.
So we've taken top 5 products and then plotted the demand.
See, what happens is Tableau and all is not a panacea for all the problems we suffer. They are all graphical display.
Yeah.
Sometimes you may have to use them with prudence. I am talking about a histogram of the pattern of demand distribution.
Sure, yeah.
How does the histogram look like in binning, categories, intervals and frequency?
Yeah, we'll get that.
If you do that, it will be nice.
Yeah, sure.
You will get a better insight. Sure. Now, it is only a suggestion. It is not that we are reducing something or you are condemning something.
Yeah, no, sir.
So, so what I am trying to say is we need not be defensive. I am
we'll take no offense.
I am also wrong in many ways. I have to just learn that.
One reason why you need to be careful is if you go back to those numbers.
Yeah.
One of the number is 4,800. So that is the reason why we are kind of little bit concerned when we see such numbers.
Yeah.
You are saying the standard deviation is 25, but max is 4,800. It cannot happen. Like there are so many outliers. Maybe have you considered all those things? If you include these things in your analysis, they'll give you weird results.
So max is 4,800 means it is measured in units. It must be 4.8.
I'm not very sure.
No, it is 4,800 units.
But it is 6 units.
Yes.
How can that be?
No, that's, I think that's, we can share
And
that.
this is over 9 weeks time or what exactly?
6 weeks.
6 weeks. So in one of the weeks there is a 4,800.
Yes.
And in all other weeks less than so.
One conundrum which you are right, Dr. Sridhar has raised a valid point. One conundrum which you have to solve is the minimum is 0, maximum is 4,800. Mathematically, the mean can be between 0 to 4,800. That means that the computer itself, you don't need a big data. Even with this, the computer will be trembling now.
Yeah.
It will be difficult for the computer also to give the output. Maximum is 4,800.
And we
That
don't
is-
have any features to even qualify. So that was another challenge.
No, mean is 6. Do you have the data? And your demand shows a steady pattern. The total demanda curve you show. Demanda. That is a demanda you show. Now Tableau will pull demanda.
Tableau PDF.
Just see this demand. This is for demanda for 1, 2, 3, 4, 5 are all weeks. 2, 3, 4, 5, 6, 7 are all weeks.
3 to 9. Yeah.
3 to 9.
Yeah.
If that is the demand in units, for this you are doing the summary. But if you go to the summary, most of the places maximum is larger, terribly larger.
I think they recognize that as well, sir. In the discussion, they do recognize that its demand is quite unpredictable. So it's, I think we'll see that as well further down. And how do we approach
For the single state, demand is unpredictable like this.
Yeah, this is the most happening state of all, because
On that day, what happened? Did you find out the maximum occurred? Do you have a next maximum?
Yeah, we have.
Did you do the interquartile range, mid range, Q3 minus Q1? You just go there. Minus 2. Interquartile range is 4. Okay, anyway, we'll.
I think the size of the store also would have a stay as well, sir.
No, that is one state demand. How can that be 4,800? I think I'm.
No, 1 million.
One state.
No, you have taken only one state, isn't it? No.
But the
demand.
number of clients within the state would be
okay.
roughly 1 million. So that's where the store formats would also play a big role. Actually, you might have a Walmart, Superstore, a Sam's Club, and you might also have.
And see this deviation, Dev, which is the Paisa or unit sales.
Units returns.
Unit returns.
Yeah.
Maximum is 14,619.
That's aggregated returns as well. So.
But minimum also aggregated.
One of the other challenges, the returns could come in an aggregated way. Say the client or the customer may not return the products immediately, and they might aggregate and send 2-3 weeks returns back in one trip. So that's why if you just subtract your sales minus returns, it could go negative.
On the
But it's
contrary,
not actually negative.
contrary, why should they return? Because it is anyway, it will perish.
No, that's how they operate. Maybe the disposal cost. Yeah, we are not interested. Yes.
Anyway, let's see. Yeah, but something wrongs that 4,000 maximum.
No.
Yeah, just go to the correlation. I think I made a comment here. This is a correlation plot. How did you get the correlation between agentia and agentia as 1? There cannot be a correlation because you know it is a number which is to represent the state, isn't it? It is a categorical representation of the state, isn't it? It's just like saying Madras versus Madras correlation is 1.
Yeah.
Because that is absurd to the power infinity, isn't it? There cannot be a correlation. Then canal versus canal is 1. How did you compute the correlation if there are demand versus value? What is that you have done? And this is also Tableau?
No, this is R, sir.
R.
Car plot. If you do car plot, it is equal to train.
But can you interpret the correlation demand versus Venta? You are saying. So there is a correlation is what? How do you interpret that? No, the correlation, the dot, you explained that. Yeah.
No, the correlation, this is your correlation coefficient.
No, so what is that? Your diagram.
Yeah.
Demanda, Venta, that blue color, your finger.
Yeah.
What you explain that? You
so
interpret.
The higher the sales.
No, that circle, what does it, that number against 0.4, what is that? What does it measure?
Pearson coefficient. Actually, right?
Somewhere between 0.6 and 0.8 is the
Pearson coefficient.
No. Supposing you calculate choral, you put in R. Demanda versus value. Just now you enter and see what correlation you get. Both are continuous variables?
Yeah, both are continuous.
You just put that. Demanda in R. You go to R Studio. It is there. You have got that.
No, you just put.
We don't have the data.
You will have to do that. I don't think it will be 0.4. There are some graphs which we will never be able to interpret, only cosmetics. Don't use them.
So this is R, sir, definitely.
No, let it be R. Even R can have some flaws. Every graph, every output in the computer we need not use, my dear.
This is the scale, sir, which says this is a scale. So this is highly negatively correlated.
But what are these dots representing? Question number 1, let me put it. Please do not mistake me. Again, I am trying to help all of you. I want to caution all of you for excessive use of sometimes computer output. There may be several things available in the computer. We don't have to select what you want. Otherwise, it is confusion confounded. There was a person who took some output. He came to me, Kendall stove. We know stove, but Kendall stove. I said, why are you clicking that? Unnecessary. What you want, you click. Then pothis of output, nobody was able to interpret. Therefore, my point is, what is the role of this graph? There must be a purpose. We have plotted it. How do you interpret this blue color which is appearing there? No, that one. Yeah, finger, yes.
This one, right?
What?
It's 0.6. It's 0.6
Positive correlation
between demand and Venta.
How much is the correlation?
0.6.
It is not 0.6. It is pointing towards
No, sir. These are scales. These are scales, sir. Red is negative, highly negative.
Supposing you give it to your director in your company and you drawn this, will he be able to say it is 0.6 from the color?
No.
It will be a problem of interpretation. Because you have done it, you know it. Second, we verify by doing the Pearsonian correlation whether you are getting that. You check that. 0.6 and all that. Because correlation is something which is very critical, very important for you. So you are showing a positive correlation based on the color. I think it's a wonderful graph. This also gives a wrong impression. It looks like a scatter plot and the dots are showing the scatterness. So kindly study this. If this has a use, you interpret and write a paragraph in this graph itself. You create a paragraph where you interpret some of the important high correlation situations. Demanda versus value and Venta. And Venta-Rin. Where it is high positive correlation and high negative correlation. For example, Venta versus the bottom is the negative correlation, isn't it?
No, red will indicate negative correlation.
But there is no red.
There is no red.
Everything is positive.
Yeah.
Correlation, everything is positive. The returns, where does it appear? Deviation.
Dev
versus demand. Dev versus demanda. But can I say more the demand, more the dev?
Not
because returns. If 1,000 loaf size I have demand and 10 comes as a return, if I have 2,000, will it not be more than 10? Assuming the same quality and pattern? So to assume no,
okay, yeah.
Anyway,
not necessarily.
Anyway, you
yeah.
proceed.
Yeah.
I don't.
No, we'll put the coefficients.
No, I don't want to give you an impression that I am trying to undermine. I appreciate all your efforts. A beautiful display of Tableau and all that, but let us interpret the things correctly. That's what you have to do.
So
okay.
We are absolutely open, sir. Please,
Yeah.
Please give any comments.
No. I am giving you something because you have to write the report.
Yes.
When somebody is reading the report, they should be able to. You should showcase this is wonderful.
Yeah.
That's what you should do.
See,
every group has made efforts, including you.
See, we are bouncing this off until now with a group of 4 or 5 people.
Yeah.
And now bounce it off against a bigger crowd, and that we're only going to get better. So in that sense, we are absolutely open to it. So,
I am giving my professional views without prejudice or anything to every group.
Yeah.
I am lauding all of you for excellent efforts made. This is the beauty of the Bangalore crowd, the most vociferous, aggressive, enterprising, participative group. But the point I am saying is, when you are writing a capstone project report, be aware that you have to interpret all of them and prepare a cohesive report, the synopsis, the highlights of the study, everything, how it will help a client. This bakery, if I apply this in Karnataka, can Iyengar bakery get some benefits out of this study? Those are the types of things you should have in your mind.
Sure, yeah.
And assignment in the LMS, 20 marks. Then don't blame me. I may be tempted to give. How many people put the correct answer? We have to see the graph. And he will be the moderator.
Yes.
Because he has done that.
I'll do my best.
But don't remove it for the sake of it. Add clarity. Interpret that. I want you to interpret. Okay, that's fine, sir. Fine, sir.
So this is a solution approach. So what we've done, so we've looked at the different variables given. So not many variables were useful in predicting the demand. So we had to create our own variables through feature engineering. So what we've done, so this is the basic approach we've done. So products pre-processing. So what we've done is taken the product, we have product names. So typically what happens in a retail outlet is products will be categorized under a merchandising group or a subgroup, and then they predict demand at a subgroup level than at an individual product level. But we don't have any data here to say these products belong to this subgroup. So we had to create our own subgroups here. So what we've done is we've taken the product name. So we eyeball the data. The product name itself has different features. It has got the name. It's got the brand, which Vardha spoke about when we saw that there's a Bimbo brand, there's a Sara Lee. So, and it also got the weight, number of pieces, and whether it's a chocolate based or vanilla based or multigrain. So we looked at all those features and then extracted the features out of it. That's pre-processing. And what we've also done is a product clustering. So there are different, say if you take buns or bread, there could be different types of bun based on the packaging. So there could be a loaf of 200 grams or 500 grams. So what we've done, by looking at the name, we've clustered the products. So that's product clustering.
That's where if you go back, the brand name we just touched upon in the first slide was very handy. So we will the brand names were actually abbreviations within the product name. The Tiana's and Sara Lee's actually. Yeah,
so also what we've also done is geotagging. So we have the agencies and the state and town, the address. So based on the town and state, we've grouped the agencies into clusters. So what we've looked into, we did some text mining on the state name and town, and then came up with a group of agencies belonging to same state and town. And so based on all these three inputs and the existing variables, we did some feature extraction. So far we've done about 18 different features. Say product and client combination could be a feature. Product, client and brand combination. So like that we've done some 18 different features. We'll come to it later. And once we've extracted the features, we've included those features into different weeks' demand. And then we've built a model, then evaluated the model, used the validation data we predicted the validation data, and we've got the test data where we don't know what is the actual demand. So what Kaggle has done is they've given a test data set, we don't know the actual value. So when you submit the model, they'll give you a score, for which we don't know what is the actual value. Yeah, it was a competition which ran Kaggle. $25,000 as a prize money.
Yeah. But I wish you all the best to get $25,000.
No, it's over.
I think where we were able to get maximum input from is the forums were there, so we are kind of bouncing off the thoughts actually, and some good people who actually have always been there and done that. So we got some ideas of them how to go about doing it. So
the correct solution?
No, they don't.
They don't.
No, there are different kernels and conversations. So from where we picked up a lot of things like this feature engineering, say segregating products based on geotagging or identifying products based on the names. So all those ideas we got from these Kaggle kernels, we asked questions and we got replies from people across the geography who participate in the competition. So
incidentally, this is another powerful feature from you. That one group came third or so in IIM Bangalore competition. Our Chennai baby, Sriram Ramanathan and others, they went and the success rate, those students who join a business school, how successful will they be in getting a good job in placement? Some very good study. And they came twice, thrice, several rounds, consulted, came to the faculty, came to me and said what we should do in the competition. I said, you try. Some inputs are given, but those who come to the competition, there will be several other people who will be competing. So take it in the stride. If you get the prize, we are happy. But it is amazing that our baby students, both Bangalore and Chennai, where I am interacting, as well as other parts, their capability is remarkable. And recently you would have seen in Analytic magazine, one student by name Balaji won the prestigious Capgemini award, which has come in the website also as a news. A Chennai baby alumni participant, a very, very rigorous competition in Capgemini. Therefore, I encourage all of you to go for the competition and win. Why $25,000, even 50,000 or 100,000? You deserve it. But perhaps that point which I am making is interpretation part. Every number we say, we should be able to explain.
Yep.
That part we should take care.
Sure.
Okay. Yeah.
So this is the product pre-processing that I mentioned. So if you look at the product name, it's got weight component, number of pieces, weight per piece, brand, has chocolate or vanilla or multigrain. So we looked at this feature. For example, there's a product, Super Bolos, 5-inch, 8-piece, 540 gram. 1 is the brand and 123 is the product ID. So we extracted, we did text mining and then splitted those names into different variables. So this is one of the features that we've extracted. And the other one is product. So there's more example on that. So how we've split different products.
These are the original contributions. And as a marketing person, that Uma Shankar professor is also here. You should market yourself but showing the best slides which will reveal your capability rather than dwelling on unnecessary trivia, coffee stains and trivia. You should not. You should concentrate on this. These are good work you have done. Text mining, how did you identify feature, then how you have used the feature to do the demand forecast. Those things you highlight and underplay the other unnecessary things.
Sure, thanks. And this is some more data we've shown how this data has been split into different variables. So the other thing, next thing we've done is product clustering. So if you look at the product names here, there are products with similar names. So they could vary based on the weight or the brand. So we created a short name for all those products using text mining and then grouped those products using k-means clustering. That's one of the other features. So there's few more examples. So if you could see Bolos is buns. So if you see Bolos BK 5-inch has same, BK 4-inch has same cluster. They fall under the same cluster. And the other thing is geotagging. So like I mentioned, there is a town to which an agency belongs to. So we've did some text mining on this and then ranked those town names in alphabetical order and given a number to each town. Yeah. So next comes the extra feature extraction.
So I think this is where we had to do a lot of, bring in all of our supply chain experience, for example. So product level features. So what we basically did was 3 to 6 weeks. We took the products and then took the mean value, the demand mean value, and then added as a feature, as a mean demand. So when we want to apply it on the training data set, we said 3 to 6. This is the product mean value and added as a variable. We didn't do any lag variable as such, but that's one thing we want to do actually, because I think we're trying to get into, somebody mentioned Arima, right? So we also want to understand how that works actually. So that's a kind of area we want to also explore. So we want to see if we can add a lag variable, especially the previous week's mean to be added and then put it as a next to another feature, time series lag variable. And see, if you see that client based info, once again, mean demand for each client. So across the product. And
what you can do is work out the interquartile range rather than the range. Q3 minus Q1.
Okay.
Approximately treat that as a volatility or a fluctuation in the demand as a deviation. Approximate it as a standard deviation. The interquartile range is far more stable, and take the median demand for each product rather than the mean demand, because median is less susceptible or it has greater resistance to fight outliers. Mean will collapse in the midst of outliers. So find out the median value which is there in your output. Median value and interquartile range will determine the fluctuation between the demand and the deviation that would take place on the upper and lower side. That's it.
One interesting thing, sir, and to all of you is, for example, root attack or the root features. We know root as a feature alone will not add any value, because root is the channel through which you deliver the product. So that's where we think, that's where we used to say, if you want to add a root feature, you got to make sure that you have a channel and the product combination, because that makes a lot more sense rather than having a root as a feature and finding the mean and applying it as an extra variable. And geo info is what he touched upon, the address of the agency. Brand features, once again, client and brand combination. This is your typical, this store plus this brand, you can gauge a certain, they will have a certain level of demand. So that's your brand features. You'll have client brand. These are permutation combinations again. So we put all this in an XGBoost because that was very convenient for us. So we didn't really have to do anything further, but pump in as many features as possible. So, but also make a very rational decision about how many features you want to pump in. Yeah, so you can go up to 100, 150, but we want to try it out first and see what the root mean square error value is and then improve on it. That's how we went about it.
Yeah. What are your views? You have been observing quite a long while. Anything special you would like to add?
No, so this part is completely known.
Okay. But you are part of that part.
He is very much part.
Yeah.
No, the first place solution in Kaggle, they've used around 300 odd features. So they extracted 300 different features and then predicted it. So we're trying to find what other features we can add so that the model can be made better.
Yeah. No, they have taken only one state and that they cannot measure seasonality or anything. Therefore, in a way, the time series part within 7 weeks cannot be determined. You need at least 2-3 years data. Supposing I take 2 months, April, May, something I put, it is difficult to even comment about the seasonality. Therefore, we take it as a data set with hardly any influence of time. Suppose you take 2-3 years data weekly, 52 weeks, and then compute something, that peak demand, lean demand, everything you can see as a graph here. Here it is a perishable thing. Within 2-3 days they have to eat bread. So we will assume the entire year you will take some bread. So not that winter season you will take more bread and summer you will take less. Not necessary. Even the cost of living index in India, the essential commodities, if you take aloo, the potato, onion and bread will be there. Bread, bun. So throughout the year we can assume. But what is important is the demand here is highly fluctuating for a variety of reasons. They are not able.
Client is one of the reasons.
Yeah.
So you're servicing million stores. One is your Walmart, one is your local Kirana. So they'll have to take care. So the demand is going to vary.
Now let's come to the cart and classification and all that.
No, it is a regression.
The cart tree and all that.
Yeah.
Because 7:30, it is now. We have to have some lunch. Dinner.
We can continue this tomorrow as well.
Yeah, no, we cannot. We will have to complete one group today. We'll have to complete. We cannot leave it in between. In cricket, you bowl the last ball.
No, but test match,
last ball cannot be bowled to the next day.
Test match you can continue.
No, test match is also over has to be completed.
Right.
Over has to be completed. That over has to be completed. That over is your group. Now, root mean square, absolute deviation, sum of absolute deviation, all this you can include. You please come to the model part and show me the results. But we have taken more than 1 hour, 6:30 to 7:30. We have given enough time.
Yeah.
So we'll give you more time.
So what we've done is we've done regression tree, because when we started off working on this problem, we didn't know it had 1 million customers and 800 odd products. So we didn't know how can we do a linear regression. It could have a equation with infinite number of variables. And so we were struggling what to do.
You have done cart, isn't it?
So we've done XGBoost. So we first tried random forest, because cart, it will build just one tree. With so much variation in the data, we thought cart may not do justice.
No, that's a mistake.
Okay.
Cart can do a wonderful job, Gini index based. Sometimes you have other models may fail, cart and random forest both will succeed.
Yeah, we tried random forest. Unfortunately, with the size of data, the program struggled to run. It didn't run at all.
Okay.
So that's when we checked that Kaggle, most of the competitions are won using XGBoost. So we started analyzing on what is XGBoost, how would it help us. So we've used XGBoost here. And we tried different models. So with different weeks. So we extracted features from week 3 to 5 and used week 6 and 7 as training data, and then predicted it for week 8 and 9. So the root mean square error came to 0.5894. The model, you could see that the model is not able to detect high demands. So this model didn't work out well. So we moved on to the next model. So here we used features from week 3 and 6 and created a model on week 7 and predicted week 9 demand. Even here the model, it was slightly better, but if you could still see there, it's not able to detect the demand, high demands here. And then we built one more model. So it's all about changing the features and then changing the parameters. So that's what we've done. So where we are, we built the third model. It's given slightly better result of 0.47 RMSE.
But you are again basing it on root mean square.
Yeah.
Go for sum of absolute deviation.
Sure.
Actual minus prediction. What is the absolute deviation? Because square suffers from, suppose the error is large, it will error square you are doing.
Yeah.
So if you can minimize the sum of absolute deviation and the convergence rule, you can use neural network for this problem. It will do, it is a universal approximation, a remarkable prediction accuracy you will have.
Okay.
It will beat all techniques here.
Sure.
You have so many lakhs, million records.
Yeah, we initially thought of doing
you have
because it
1 or 2 hidden layers with 40 nodes and run 5,000 to 6,000 iteration put there.
Okay.
And use Garson's model of global optimum, which is available in R. You will get a better accuracy.
Sure, we will try that. Yeah, sure. So as a next step, what we thought, because the number of features we have passed is around 18, so we thought adding more features would actually improve the accuracy of the model. So
you will overfit. You don't have to do that. You will overfit the model.
We also want to introduce some lag variables. I don't know what your thoughts are.
But lag variables for a 6 to 7 weeks,
yes.
how does it help? I don't think
It doesn't. Okay, right.
machine learning, all of you are seeing, I'm saying is digital prediction, image, Facebook, so many things, including Flipkart, Amazon, 15 hidden layers with millions of records. One gentleman from Flipkart, data science, he came and explained, I think your batch only inaugurated. What a wonderful presentation you had. So they are using neural network multi-layer perceptrons. And the bias in the neural network is like the intercept in your regression. And predictive accuracy, neural network, random forest, both are black boxes in terms of lacking explanatory power, but remarkable predictive accuracy. Random forest is nothing but a series of 500 to 1000 trees. Each tree is a cart, and it maximizes the accuracy by selecting the best tree. So it avoids overfit to a large extent, but it is very black. It is perhaps sometimes you may argue it is more black than neural network also. Right. Which one is more black, difficult, is also a black box. Variable importance you can find out even from decrease in the Gini index. So CART, support vector machines, neural network, random forest, they hold the future. Machine learning, both supervised and unsupervised, will be the future in predictive analytics. That is how the whole thing looks like. So we will have to master them. To that extent, they have attempted something extraordinary given the time. Whether they win the competition or not, I admire them for their efforts. But I am trying to say, can you do a neural network? Can you base your demand on median and interquartile range and see how it behaves? These are the things, if you incorporate and submit your report and the hard copy, that will be wonderful.
This brings us to the end of this tutorial on market basket analysis. Now, before you guys sign off, I'd like to inform you that we have launched a completely free learning platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. So guys, thank you very much for attending this session, and I hope you have a great learning ahead.